The comments are like, he's an Onshape employee. Get the Onshape employee back. I don't work for Onshape. I work with Onshape. There is a distinction.
Yep. And we are going to go through 8 lessons today, so we can see on our schedule here that we're going to start with how to set up motion study for vibraphone design. It's a typo there, it's my bad. And we hope that this will be super valuable for everyone. And during these 8 chapters, we're going to try to let Derek follow his train of thought. So we're not going to read out chats that much during the chapters, but between chapters, we're going to check in with Hannes so to see what's happening in chat as well. Sounds good for everyone?
Sounds absolutely fantastic.
Awesome.
Sounds good to me.
And stream looks good, Hannes, everywhere? People are happy?
Yes, we are live. It was a little bit of hassle in the beginning there, but we're live now.
Awesome.
It didn't work as it said it would, but we're live.
Good. So, first of all, it was super simple to share this CAD with Derek. I sent him a link invitation, and now I have a little green symbol up here. Well, sorry about that. That tells me that Derek is in this document, and I can actually switch here. And now we're watching Derek's screen. So, motion study, Derek. And just to say, like, why I had this problem is that I want to discuss with my self-design if the vibraphone place should move, but then I also want to do some cool design for the programming of the dampeners and stuff like that. So then I want to simulate how the programming wheel can control things like that. So, and I never done anything like that in Onshape, so I'm going to leave it over to you, Derek, on how to do that.
Okay. So when it comes to motion studies, Onshape gives you several tools to achieve them. Maybe not the most advanced possible tools. Like there aren't full like simulation context sets. So for example, if I switch over here to the vibraphone tab here, something like a cam geometry where we have these bearing rollers that skip up and over like multiple planes of material at once. There currently isn't an assembly mate that does all of that level of complexity simultaneously, although there are custom features that people have worked around to adapt to that. But starting off with the basics, the very simplest kind of motion study is pretty much the one that you did here in this sketch, where you do a very lazy 2D dimensional representation of what the linkages are and where they're supposed to be, and you set equal constraints in the sketch, which I don't see here, but we'll go ahead and add them now just to illustrate the point.
Yep.
You can do a lot of assembly study in a 2D line work without having to go to the level of three-dimensional CAD. Now, that does work only if all of your parts are simple and can be expressed in 2 dimensions. So if you have something like a vibraphone reader that needs parts to lay out of plane, maybe something is going across some angles, which I think some of these might be in the final design, although you would know better than I would. And if you're in one of those situations, you're going to want to start to do a subassembly of all the mobile components. It's good that you set this up in the document the way that you did, because it's an isolated, non-blob-based study for like early reference. We can talk about how to do this in a blob context in a moment. But what I would start with is drawing out some of your parts. And this being a like skeletonized sketch, there aren't like full lines that or like full regions. Like here's one, but that's not a real part. That's the space in between some parts.
Like what you can do, you can ignore all these sketches and just do a cam and follower example on the side of this. I think perhaps it would be even easier for you to just ignore all my mess there.
We could do that. Yeah, let's go ahead and start a new document tab, and we'll try like just a 3-part linkage, the simplest possible.
Sounds good. Just a basic workflow on in. You already said it's in an assembly, and that's kind of the knowledge that I'm lacking now. So just the simplest example will do perfect. And Derek is actually using a sketch, which is surprising because he hates sketches, which is point, I think, 5 on our to-do list today, to explain to everyone why Derek hates sketches and why you should
We'll get to it.
We'll get to that. The hyperbole.
I said that I will not disturb you guys, but Ludwig is in chat and he is asking Derek to could you please select the Teams app and press Control Alt Shift plus T for smoother screen share?
That's the kind of interruptions we accept today.
I did the input. I don't know if it worked.
Okay, thank you so much. And thank you, Ludwig, for keep an eye out.
Ludwig with the sorcery. Yeah, it's a bit choppy, but I think the knowledge will get through. Perhaps between these chapters, we can spend some time on seeing if what we can do about that.
Yeah, let me know if we need to take a break for that. So what I just did, where I did a skeleton sketch and I did a couple of extrudes for the points of illustration, I probably wouldn't approach linkage design this way, but it proves how you should do something like a 4-bar linkage study in an assembly. And all I did was I did 4 linkages of different lengths. I did a thin extrude and set to mid-plane, so I didn't need to do all the offset profiles. And now what I'm going to do is I'm going to set up mate connectors that are attached to each of these bodies.
Sorry, Derek, what is a thin extrude?
Okay, so I was going to get into this later, but I noticed in a lot of your other sketches, like, for example, the frames on these, the sides of the machine. If I go switch to...
I'm always making a midline, and I think a thin extrude lets me use the midline for the extrude. Is that true? That's a fantastic...
Right, you only have to define one single profile, and then everything becomes an offset from that when you use thin extrude. So all of these extraneous bits of line work here, where you have the center line, and then you have the offset of the profile on one side, and you have another half offset on the other side. All of this could be done as a single line center sketch definition, which should save you a lot of time when you're doing more complex geometry.
That's fantastic.
Where you don't want to spend all your time with offsets.
Yeah, these are the kind of sketches that nightmares are made of for Derek. That's why. So can you go back to your example of the linkages and just show once again how you extruded only the lines done? Is that what you did? And is
yes.
thin extrude is thin extrude in the normal extrude thing?
So you notice that every Onshape feature, well, the Onshape features that have options here have some solid options, some surface options, which if I select the curves of the sketch, this won't draw solid geometry. It'll draw a surface instead, which is a 0 thickness sheet. That you can use for other operations, maybe split features, maybe a thicken operation if you're going to be doing surface modeling for injection molded product design, something like that, maybe even 3D prints. I don't typically use surfaces by themselves. I tend to work in solid definitions from the jump, although there are instances where I will get into a little bit of surface design. So you can select the entire sketch and with only... single line segments, do like a 10 millimeter thick, like width-wise offset. And you can set that not mid-plane. You can do 10 millimeters one side and 2 millimeters the other side. Dimension for you, you can do that. You can flip the walls.
Amazing. Okay.
And then the usual depth options apply.
Thank you.
Now, I did not... all of the edges of the sketch because this is one resultant body. I want 4 individual linkages. So I did these 2 lines to 25 millimeters, I think is default. Set that to mid-plane. Dimensions don't really matter here. And then I did a second one with another extrude so that I got 4 individual parts. If I were to do all of them at once, it would draw one single part.
Got it. Sorry,
Yeah,
I
for
derailed
example,
you from the motion study. It's just that I never seen that before. I'm very happy to learn that already. I can sketch a midline and extrude that as a frame. That's fantastic. Thank you.
Yep. So what we're going to do now is we're going to attach mate connectors to each of these individual bodies because I could go into the assembly right now and start doing mates on all these parts, but it's better practice to try to define positions of rotation or fastening in the part studios. Because then if you use the parts in multiple locations, you don't need to go reattach mate connectors at the assembly level, if that makes sense.
Yep. They're always in there from the get-go.
which I suppose I could use the sketch itself because everything was defined by that. So we'll just do that. And I'll go highlight one of these parts and show it. Part 1, owner entity. I should probably label these, but they're going to come in attached to the body. So actually that doesn't matter. Something that could help speed this up, by the way, I have a custom feature that I called polymates, which default Onshape mate connector feature only lets you define one of these mate connectors at once. With polymates, you could define multiple of them and attach them to a specified owner part in one operation so that you have less feature tree clutter.
Yeah, if you want 14, that's gonna save you a serious amount of time.
Right.
Yeah.
If 2 is not like the most representative example, but 14, definitely you don't want to be doing all those manually.
No. That signal means nothing.
You just want.
I think it means CAD is happening.
CAD is happening.
Or perhaps this is the dream setup. Derek build the machine and you play music, Martin.
I'm just enjoying this so much. So, yeah, to catch any new viewers up, we're on chapter 1 of 8 in this stream. We're going to learn how to do a motion study in Onshape, and Derek is just setting up the document here. So far we've only been in the part studio, setting up the parts and there some mate connectors that I guess will be used in the motion study soon here.
Okay, so there's my setup. Everything should be done here. And now I suppose I could take a second and show like the other like trivial kind of motion study. Like let's say you don't have this linkage here and you don't want to go through the trouble of going to a full assembly motion study because it's a lot more things to set up. It is perfectly valid to just stay in the same part studio just to get a like gut check and then do a transform rotate, go select like this mate connector and then these two bodies. And if you want to check that that part swinging 30 degrees isn't going to hit something, you could do that in your part studio. And that is one kind of motion study that you can do.
So
now,
the simplest level in a 2D sketch, next level up, a transform in the part studio.
Yep. This does have consequences down the line if you like leave these live, and you might need to put these into a folder and suppress them. So it's more an avoidance of having to go to the assembly level than it is like quote unquote good practice. But sometimes you just need to get answers quick.
Yep.
And it's there for that. Right, now we can go to the assembly or create an assembly rather. And last time I was on stream or in the recording, I recommended that at all times when you're doing part studio insertion into an assembly, you do insert entire studio as rigid. This is the exception to that rule. And it's when you have mobile components, and I should probably label this so it's easier to find. Part studio 1's not very descriptive.
Derek forgot to name the part, Hannes.
I'm just waiting for the chat to explode.
I would never do such a mistake.
You have never done it.
No.
Not once.
I have shipped entire jobs with like tens of thousands of parts named part 1. Chat would be furious with me. But sometimes labeling the parts takes longer than it is worth doing. So honestly, if your data, like if your management of part information isn't handled by the names, that's fine.
Yep.
Right, so I'm going to look for motion because that's what I just labeled that. And I have this demo motion studio here. I'm going to insert part 1, 2, 3, and 4 all at once, which should bring them together like in relative positions if I selected all of them. Might look too fast. I'm going to clear that again. Insert. Motion. Oh, there we go. Whole studio works. And I didn't select the sketch because that's not relevant to what we're doing now. I just want the part bodies, and they come in. They already have their mate connectors attached, and now I'm going to separate them out a little bit. And I'm going to right-click this one and make it a fixed linkage so that that one can't be dragged around, it can't move, but this one up here can, that one over there can, that one over there can. And then I'm going to enter my mate dialog. And we're going to do all revolute mates for these because they're all like rotational and not sliding. So you could always change the mate type after it's defined. Maybe you want to change one of these to a like fixed mate, or maybe it's got some sliding action or cylindrical action where it can rotate and slide. Think something like sliding along a shaft that can also free spin around it. This example, all rotational, so all revolute mates. We're going to grab that guy there and that guy there, and that's going to snap that there. And when you confirm that dialog, it maintains the last mate type that you specified. So you can grab one of those, same thing, and then work your way down the chain.
Got it.
And if you needed to, you see how those were overlap when I first got over here? It would be kind of hard to select both of those. You can always drag something out of the way so long as it's a click and hold drag. It won't select like one of these implicit mate connectors, like that guy. We're not trying to mate to that guy. So click and drag prevents that from happening.
We're not trying to mate with that guy, okay.
Yep. We're only trying to do the like explicit mate connector of part 1. I probably should have labeled those as well, but demo purposes. All right, now all those are set up, and I have one of these items in the tree that is fixed. If I have 2, both ends are fixed, it's going to throw yellow errors that says, hey, that one's supposed to be my ground truth, but that one is also a ground truth. Nothing in between them can move. You're only supposed to have one fixed part per assembly.
Yeah,
is the recommendation. There are times when I have more than that, but they're usually to be avoided. So now we have these set up. All these mates define like the true mechanical constraints of, I'm going to just call this like a suspension for a car. Maybe if I come back into here, draw like a pseudo wheel.
Sorry, Derek, did you already stick one part in space? Did you fix one part already?
Right, that was what I first did when I came in here. Part 1, I right-clicked it and then did fix. I can unfix this, and we could, maybe we switch over to this guy is our fixed component.
Okay.
And we could reverse the action here.
Okay, right click and fix. Yeah, I see your screen a little bit small here. So and also when
speaking about Derek's screen, it's okay if I interrupt a quick here, because Derek, Ludwig sent you a message on WhatsApp to try to increase the frame rate from your screen.
Yeah, let's do a break for that. Actually,
that could be really good to just fix that.
Yeah.
We have like 1 FPS at the moment from the screen, so there is a button you can press to optimize.
Control-Alt-Shift-T.
And did you see he sent you an image for a special button you can press?
Yeah, it says optimize. I wish I had that button because I don't see it.
Okay.
Are people happy, Hannes, in chat?
People are happy. People are very happy. I will take my time right now to announce that we have gotten several new members. So we have new YouTube members here coming in. We have Austin's Curvin01. We have Pluto Games that subscribed on Twitch. And then we have, of course, our very best friend, Marcin Kowalczyk, who gifted 5 memberships, just as he said, just to celebrate this collab.
Yeah.
So thank you so much. And Colonel Panic 420 says, oh wow, 1 minute in and I'm already learning. So I think that's that's the gist of it. People are happy.
Perfect. Is the frame rate happy?
That is a Ludwig question.
Ludwig is our sorcerer.
Austin's Curvin says yes, he's enjoying it at least. And David Becks, even with 1 FPS, this is so good.
For me, I think the FPS is just a comfort factor. I think we can follow completely what Derek is showing us. So
Probably yes.
was the optimize button not present, Derek?
It's not there, and I'm looking for anything on Google that says optimize for video. I might have to like stop sharing and then reshare maybe.
Okay, let's try that, because it's
Switch
fun.
over to your screen then, Martin.
It's fun to, okay, we're gonna go to my CAD. So here's my CAD with the same, and it's pretty funny. I'm here in Onshape, so I have the motion study Derek just made. So now I can go into this feature tree and see what Derek just did here. And I want to go back and look at that thin extrude. So it's edge of sketch and then thickness. Yeah, this I never seen. So here's the thin extrude that Derek changed. So and then what did Derek do? So now I can drag, or do I need to transform to drag stuff? Oh, we have frame rate on Derek is fixed.
Yeah, it seems a lot better.
Fantastic. Well
Perfect,
done, Ludwig.
Derek.
Thank you, Ludwig, and great job, Derek. So now we're back on Derek's screen, actually, and frame rate looks fantastic. So keep on going. We're going through now how to make a simple motion study in Onshape, because I want to do that for the vibraphone programming stuff.
Okay, so this is the basics of how to do like very simple geometry for 4-bar linkages, which are kind of complex to solve for in a 2D sketch context. I mean, you could do it, but you end up wasting a lot of time with equal constraints, making sure that you're selecting the right sketches or like sketch lines. Maybe you miss one, and it doesn't show you the full motion path, where this does give you a nice sweeping arc, where this thing starts pretty like high up and parallel, and then it like levels out to more of a canted angle. You wouldn't be able to get a lot of that from a purely 2D sketch.
Could you do like an angle controlled animation? Could you tell Onshape to do 15-degree swivel of one of the pivots?
So that is the other thing we can do, is I think we can set these up to
with limits.
See, edit positions. You can set name positions. How do I reset these to defaults? I know there's a way to do it. I just haven't done it in a while. Normally, a lot of our stuff is static, or we tend to do one of these studies in isolation and then not put it back into the main assembly because it's not worth the rebuild time. You prove the concept and
yeah. Okay, so actually, in the sake of time, perhaps we shouldn't delve deeper, because we're already half an hour in and we have so much meat to go through in the other subject. So basically, make the parts, put mate connectors on them, go into an assembly, and do it there. But it sounds to me that there's less features in Onshape compared to, for example, Fusion 360. What I remembered, it's very bare bones.
Right. So I'm gonna let's go talk about the contact mate. This is the one that probably you'd be looking for, like rolling up and over a cam that will be multiple surfaces. Mm. Technically speaking, the closest you can get to that right now in Onshape is a tangent mate, I believe, which is a contact mate, but it's only constrained between like two sets of faces. So you could do a cylinder across a plane, or a cylinder across another cylinder, or something like that, or like draw some like crazy spline shape, and it'll follow one face, but not multiple faces in a chain. There is a custom feature that somebody wrote, though, that helps get around that, which I did not pre-prepare, but I could follow up with the link to that later.
Do you know
essentially
the name
what it does is it no, but I can look it up between breaks.
Yeah, perfect. Yeah, so in a question of time, I think I'm happy with this one. Thank you so much for showing. I know where to go, because I think there are so much fun more stuff to get into. So we're not. So what do you say, Derek? Should we move on to the next step?
I think we should, and we actually maybe skipped lesson 0. I know it says 8 Onshape lessons, but there's a secret ninth one that I did want to point out because I'm going to do some other stuff that probably you want to undo.
You were laughing
And
at
I
me in our
noticed-
chat. So, Hannes, you can close the graphics. So we're getting a bonus lesson here from Derek. When
Ooh.
Derek went into my document, my machine document, he was like, we got to talk about something, Martin. So go ahead, Derek.
So we got to talk about versions because you've started this document on March 2nd and it's never had a version applied to it. This is still technically version 0 of Marble Machine for World Tour V1. And that's okay if you want to hunt through millions and millions of changes down the line and you remember all of the things. Now, you can see that the micro versions are all saved. So every single motion thing that I did in the assembly is saved for reference later. So if I wanted to roll back to exactly like this time that I did the insertion of part 1, 2, 3, and 4 into the assembly here, I can go there. Or I can roll back to even before I started today. This was the first one that I opened the document in, this version here at 11:30. I can retroactively make a brand new version and save this as V1. Or you can give it a more explicit name, like before Derek touched things.
But these are not backups. These are shortcuts to wherever we were. So what's the benefit of, why is it a better practice to do more versions?
So I like to save them as explicit like checkpoints of changes in design intent or like something significant happened at that version that I might want to go refer back to later. Like maybe I'm going to go try out a case study between last stream you did the wide machine and you had to go make some changes to the master blob to go see what it would look like if it was wide. It's good practice to make a checkpoint that said before wide version experimentation so that if you go edit the blobs and things don't work out the way you want, or the most catastrophic thing you could do, like if I were to right click this and then delete the master model, it's going to tell me that deleting this tab will result in failed or missing features in 38 tabs. That'll blow up a project. So there goes the master. And now everything is broken.
Thank you for deleting my entire machine, Derek. I appreciate it.
Woo! But it's okay because we can roll back.
You really trust
at any point in time.
software. This is making me very nervous here.
Oh,
and it's all back.
Okay.
Just like that.
Good.
My coworkers have a policy that anytime I sit down at their desk, they're like, make a version. He's going to do something catastrophic.
Okay, so also for me, when showing people I realized when I did a weekly recap, I realized I have no clue how the machine looked 7 days ago. And I was trying to go through the live stream to get an example. I ended up being so stressed for time. So when I recorded that video, I couldn't show the progress. And it sounds like for me, especially having a lot of versions, I could just on screen, I can just go to, this is what assembly looked like a week ago, this is 6 days ago, this is 5 days ago. So for storytelling purposes, I think this is brilliant. Thank you so much for showing me this. And next time I invite you to stream, I'm gonna make a version before I let you in.
I apologize for not telling you that I was going to delete your whole project on stream, but it's probably the most dramatic way that I could demonstrate that, and I think it gets the point across.
Super. You know what I missed in the beginning of the stream? I didn't read all our fantastic subjects that we're going to go through. Perhaps I should just take a little bit of time to read this also. Everyone can see what all the goodies we're up to. So now we're going to talk about how to create nearly identical objects without having to do all objects manually. Perfect example is vibraphone plates, 37 of them, same shape, different sizes, resonator bars, vibraphone funnels. Then we're going to go into why sketching on mate connectors solves the C-flip issue, and also when to sketch on mates and when to sketch on planes. Then we're going to see when you have sub-assemblies like the marble gate with a lot of parts, where do we duplicate them? Do we duplicate them in the master assembly, in some part studio? I'm confused about that. Point 5, we're going to show why Derek hates sketches and why you should too. 6, we're going to talk about Amalgamate, which is a custom feature from Derek. I asked Derek, do you want to demo Amalgamate? And he said, no, you want me to demo Amalgamate. So apparently I want him to demo this amazing feature. I saw Evan Reese's video about it, and it's cool stuff, I'll tell you. 7, understanding and working with context, what geometry to use and not use. I think there is some really important knowledge from Derek there. And then 8, we're going to go into blob mania. Working with blobs. Why is it called blobs? It's Derek's naming convention. And we're going to talk about shapes and sizes of the blobs in the Master Part Studio. So we have a lot of goodies to go through, but let's go into subject 2. How to create nearly identical objects without having to do all objects manually. Hannes, do you want to say something from chat before we go into the next subject?
Yes, chat is happy, and I'm happy because I'm just gonna mute our graphics. Give me 1 second. There we go. Because we get new members like Kevin Middlesworth that says, hoo-hoo, long-time lurker, first-time member. Then we have Mr. Gonzonator who says, wow, that FPS boost has released my tension headache. So they're really happy about the FPS boost. Great job, Derek. And then we also have a nice little donation from Hasse8745. A new joy in my life to have these regular streams. Plus, it's great to see Derek again. Keep up the great momentum. And then Hazel Blazer with the comment, Derek is a monster. And big up Derek from Nathan.
Yeah, awesome.
The whole deletion.
That was
a ballsy move, Derek. Ballsy move.
The truth is, because Onshape saves every micro version, it's really, really hard to break your document in a way that you can't recover it. I know, I have found ways. They're really, really specific and esoteric, and the support team has gotten to know me well, but you're unlikely to be able to destroy your own project in the same way that I did.
Sounds good.
All right.
New subject. Subject 2. Go for it,
So, identical objects. We said we were going to do the vibraphone, so let's go try to switch over to that.
I think the vibraphone bars is a good example because it's just rectangles. And then I want to do it for the funnels that are more like fancy, but let's do just these rectangular bars.
Okay,
so
what you've done here with the... Actually, I'm just going to roll back up.
Don't show them my dirty laundry now, Derek. Well, do. That's of course the tutorial. Okay.
So this isn't like a terrible approach to this. The linear pattern of a feature like a extrude is one way to get repeated geometry, but these are all individual parts that don't have any like future tie to each other, so you can modify these, like move one of these faces and it won't have any ties back to the original geometry, which might be something that you intend, might not be something you intend. But this is a pretty good quick approach to doing repeated geometry, but you pay a cost and consistency on these objects. Like if something did need to change on one of these and propagate to all of them, it's better to set one of these vibraphone bars up in an individual part studio and then make it configurable or usable in some other like assembly insertion. And some ways to do that, in the context of a single part studio, you can use variables, which you already did some exploration of with the variable studio here for actually, what did you make with the variable studio here? Let's go filter by that.
We made the ceiling height.
Ceiling height and frame thickness. So you could do some controls there. Although if it's a document level variable studio, it won't be on a per part basis. You could do them using the inline variables, which you can define using the variable feature, standard Onshape feature somewhere up here. And there is a tech tip that Onshape themselves have written on how to define one of these features as a single instance and set it to a value and then do a like single one of these extrudes, for example. Like draw one of these to that variable's distance, which I suppose I'll just make a new document now and show that. Part Studio new. And we'll just go draw a sketch face on.
Derek named the part studio. He doesn't dare not to anymore. Not in on this stream.
He deleted your entire machine. He got balls, Martin.
And we'll go set that to go one direction, and we'll go make a variable here that is new variable bar length. And same as you did in the sketch, if you define a variable on the fly like this, it'll spawn a new feature in the tree above that. So this one's going to be set to 25 millimeters. And then we could do another variable after this, so that we do this variable is going to be equal to, actually it's going to have the same name as the bar length feature, or variable feature that we defined before. And this is a like programmer's workflow. It's a little bit outside of the normal like CAD brain, where you don't normally think of CAD as a like programmer's tool, but this is all software like running on a cloud server somewhere. It's all software defined. So things that work in standard programming context also work here. So if I set this variable for bar length equal to the previous bar length variable and then multiply it by some value, so we'll just do times 1.1, and then I do a linear pattern of this feature, that one there, and I do the bar length, and I do direction. I'm going to pick this plane here, and I'm going to set those off some distance from each other. Did I do that right? We need to switch the order of those. Hang on, I'm gonna read the tech tip real quick.
They should go on multiply each other over time, so they should become longer and longer somehow.
Right.
That's sorcery. So I'm also learning like from Derek that Derek does something that I never do. He goes to the documentation. He goes and asks what Onshape. He goes and checks what Onshape says about stuff.
What?
Yes, I think.
Yeah, as much as I know about Onshape, I mostly know where to go find the information about things I don't know about Onshape. That's the main thing to know about using Onshape, is that it's got lots of like online resources, the forums.
That's
Discord
really inspiring. Like better than to give someone a fish, teach them to fish. That's you're teaching us to fish here.
Well, I could show the example here where they use a slot spacing thing where they do individual like definitions of slot width, and then they set a second instance of the variable equal to the first one plus 0.05 inches. And then they do a feature pattern of the extrude with the direction and then the distance. The distance changes in the feature. Okay, that's how they do it. Second pattern must include slot width, slot count, slot spacing, slot sketch.
I think it's super cool that you're figuring this out on stream, Derek. So don't feel stressed in going this fast. I think we'd love to see real problem solving here, and we're learning from how you are taking in this info. So don't feel that you have to rush through this.
You can learn something as well, Martin, with this. It's okay to take time and learn stuff.
Yep.
And don't get frustrated.
I was actually to a Google conference yesterday with with DeepMind was there to present their latest AI features, and their tech demo didn't work, and the presenter said, "I know why it's not working, but I know how to get it to work. But let's move on." And I felt the whole room of developers. It was kind of the most interesting part of the whole thing. It would have been so nice to see the presenter work it through there and then, so they just left it not working. Which Derek would never do to our look what's happening here. This is crazy.
Now, and this is like classic like debugging. I just forgot to check this reapply features box.
No.
I'm patterning this extrude feature and repatterning this feature, but it's not reapplying them. It's running the results of these features, not recalculating them on like the next iteration of the loop. So that's a very simple mistake to make.
I can tell you, I've done that mistake a lot of times. I'm like, why is nothing happening? And then reapply features. I don't actually understand that language of the dialog box, reapply features. Let's not go into that right now. Okay, so now you define like how much longer each bar. But this is of course then setting that the multiplication is the same all over the spectrum here.
Right. So this is like a, previous result times the same thing plus 20%, which some, I think music scales work like that sometimes. So that might be the intent. Or maybe you want to do like a linear change where this is like plus 5 millimeters every time. And you could do that as well. And then that changes this from actually, let's do a bigger value so you can see them. Let's do 15. It changes it to like a linear change between each scale. So if you have constant change, or I guess that would be not exponential, but geometric change between items, that's one way to do this.
Yeah.
Another way to do this, and I'll duplicate this tab here to show these both off.
Because this is, of course, nice if the change is steady, so to speak. But in the chance we want them all like individual, it's not always going to work doing it this way.
Right. And I guess now would be a good time to talk about the types of variables, because this is just one kind of variable. In Onshape terms, there are like 5 or 6 different ways you can define variables. The one being the variable studio, document-wide variables. This would be a variable feature or explicit variable. Both of which should show up in the side table over here on the variable table. It'll tell you that I have bar length specified in this document tab, and then there's the global ones from the other variable studio.
Yep.
But the other way that you can do variables, if you wanted to just, get rid of all of these and then define a single extrude one time. And here I broke the feature because I no longer have a variable called bar length. I'm going to fix that right now by creating a new variable using the configuration panel here. And we're going to create a configuration variable. Now, what this does...
Derek, can I ask you to try something? Can you just increase the browser size with like Command plus so we get a little bit more zoomed into Onshape? Because it's a little bit small on screen. On Mac, on it's Command plus. I don't know. Yeah, perfect. Then we see the dialogues a little bit bigger.
Oh, I don't have that fancy zoom like you do.
But this
actually, maybe you want to do with it. You might want to do this on your own as well for practice. But so here in the extrude, I don't have that depth variable anymore. It's broken.
Yep.
So I'm going to copy that name because I'm about to remake that variable, but through a new window on the right side of the screen, the configuration panel. And we're going to create a configuration variable for length with the same name of the broken variable. We don't need hashtag because it defines itself. And here you can set parameters for your variables, where you could say the minimum length that I want this to ever be is, we'll say 25 millimeters just for consistency with the last example. Maximum length is, we'll say 1,000. And then you set a default where, maybe the average one of these bars is 100 millimeters long. So in just setting up that variable in the configuration window, you see this new item pops up in this configuration window up here, where you can define bar length to whatever you want. It could be everything in the geometry that's based on that variable will update.
Wait, so then if I do, can you make a part next to it and then configure that? Like, if you want to play it next to it, then you can just configure that differently, or how would that work?
So this is where you wouldn't do that because you've set up this one document. This we'll rename this one configurable variable vibraphone. This is where you might want to do your configurations in an assembly or in an amalgam context, which we'll talk about when we get to that.
So would I then have 37 part studios? No.
No, you only need the one, because if you go now create a new assembly,
It's so exciting because I don't know at all what Derek is going to do next here.
Oh, you're all giddy.
Yeah, this is
This is
my
Christmas
Super Bowl.
for you.
This
Oh,
is
this
my
is your
Super
Super
Bowl. Yeah.
I got too many vibraphones in here. There it is. This one I am inserting as rigid because I'll add stuff to it later. The resonator tubes are probably a good example to show underneath this. So we'll do that guy gets inserted there. Now, I do want to preface this with I don't think Onshape has a good way to do linear patterns of configurable parts and then change every individual configuration. So this is sort of a prelude to why I'm going to break some Onshape canon and tell you why Amalgamate's great later. Because I can change this one instance from 100 millimeters to 250 millimeters, and it'll update both instances because the second one is a pattern.
Yeah.
So I can't change the configuration of this without also changing this. It's an improvement request I have open to be able to like vary individual parts in a assembly, but for now, that is not a capability of this. But you could insert, we'll just delete this pattern, and copy and paste this 35 times. Oh, can you not copy in an assembly?
That's a good question. Actually, I had the other day. This makes me happy. Even Derek.
Replicate works.
Sometimes. Replicate. You're reaching for a custom feature.
No, replicate. There's no such thing as assembly custom features, unfortunately, which is why I spend a lot of my time in the Part Studio context. Is because I can make features exist when I want them to. Okay, so we're just going to insert the same studio 15 times, and we're going to vary every single individual one.
Okay,
you probably wouldn't do this. I wouldn't probably recommend this, but it's an option. And maybe for something like 4 items where you're going to do a couple of these, this is fine. So you can right-click each one of these individually. Right-click this here. Change configuration. We'll do 300.
Okay, so now you're not changing the variable at the beginning. Globally, you're just saying right here, the configuration is like that. That was like when we did the sorting, the Gridfinity sorting boxes. Ludwig built that up. So how many do you want 4x4, 2x2? He did what with used configurations to do that. Okay, nice.
Yeah, so you could build it out in the assembly, and that does work. There are more steps doing so, but one of the benefits to doing this is that if you need to make changes to this and make this more complex, I'll go ahead and put we'll just do a circle on the bottom of this to represent the resonator tubes. It's not real, but it doesn't need to be.
Good.
And then we can tie this to that same variable. I don't know what the actual relationship is between these, so I'm just going to arbitrarily say it's like 0.8 times the same length, and that's a resonator tube. Now, if I switch back to the assembly, once you've set everything up and you've got it all kind of configured the way that you want, assuming, yep,
wow,
I did all those as rigid, all those resonator pipes come in, and that's a way to get to a more replicated structure without having to redo all of the individual features. I did want to point out in this, any single Part Studio does have a regen time. So doing things in a Part Studio that are heavily repeated has a performance cost. Mostly. And there are ways around that as well. But this is why Onshape recommends that you do assembly structures, is to avoid paying this performance penalty and having a 120-second rebuild time on your Part Studio and going, why is my document bogging down? Well, it's because you had 800 lines that are all filleted, and filleting can be an expensive operation.
Okay. Did you see my funnel example? Because it sounds like there's still kind of a lot brute forcing. This is neater. What the two methods you have shown me is much neater than totally brute force it and do it manually. But did you see the cascading funnels I made? Those are a little bit different. Where I want to kind of those are not the ones.
Not those ones.
No. Funnels 2 it's called funnels 2. Just with yeah,
There it is.
this one. So and then you have to roll back, yeah. So like here I would like them all to start at the same point, and then I want like think of it as laser cut steel profiles or CNC plywood profiles, and I want them all to go by the pivot point. Like perhaps we shouldn't go too deep into this, but on the top of your head, like, is this actually a case where I do have to draw 37 sketches?
37 sketches, no. Because how did you do this? You did a pattern, and you did a curve pattern, right?
I followed I did it. I didn't do it neatly. I followed the curve pattern of that arc, and it didn't end up in the correct place. So I did, yeah.
Because it's saving the dimension from like the hole down to the curve, and then as the curve changes from side to side, it shifts it a little bit every single time. If you set up the curve pattern right and had like a good spatial reference, this actually isn't like a terrible way to do this. Especially with the regen time is under a second here, it's fine.
Although it was not the result I wanted actually. So I don't want them to be similar in a different place. I actually want them all to have their own curve. So it's more the sketch profile I wanted automated.
Okay.
Because I didn't just want them to follow that curve. I wanted them all to be a little bit individual. Yeah.
So that probably does lead us into topic 5 with sketches and their limitations. Because if you're trying to do something like this with a lot of like particular geometry that relies on variables, sketches give you a lot of options for like local in context things. But there are other tools that are a little bit more consistent, I would say. Maybe we should take a break and like talk about chats.
But basically what I'm hearing from you now, Derek, is I'm not missing like the obvious, the magic button that would just do this for me. It's not super straight. There's not like a super straightforward way that you can just show me in 5 minutes and then I know how to do it. There's many ways to do it basically, and there's not a like super simple option.
It would take some setting up, but we can do it as an amalgamate, and we could also set it up with a query pattern with Evan Reese's custom feature. Now, he has a whole video on the same kind of like parametric building instructions, and I could show you some examples from his custom feature document where all of these things in his example studio are defined parametrically. It's extrude with the draft, and then he pulls the inner edges to fillet those, and then he does a pattern over the entire assembly, or not assembly, part document, where it applies the same operations with slightly variable geometry. So there are solutions, but setting this up is a little bit more convoluted than can be shown in a 5-minute segment.
Yeah, let's not do that now. You've shown us the future. We need to be a little bit light on each topic because we have so many great topics to go into, and
like something like that.
Okay, that's really cool.
Great. We'll go into the next topic really soon. I just want to give some quick shout outs here. We got a nice donation from Martin, our dear friend, that gives us a good reminder that remember, slow is fast, slow is safe, no need to rush. That's always good to remember, folks. And Ludwig has a question for Derek. Derek, do you ever use final preview for finding the values?
Sometimes I use it more for like visualization, like Martin was doing in previous streams. The issue with using final to try to like drive like part geometry is that, you know, some of the other geometry can change. So I would prefer to make references explicit and like automatic. So something like a blob face-to-face reference, or actually another version of variable, the measured variable is a more stable way to do, like, rather than trying to predict the future by using the final button, you can explicitly go measure other things in the studio, like here. Where was my, I think it's still labeled copy. Here it is. Another way to do variables is using the measure tool, bottom right of the screen. You can measure between entities. So if I pretend I didn't have this bar length here, and this was a geometry pulled from somewhere else, maybe it was an import, maybe it was something that I drew in another studio and then derived it, and there is no variable that controls it. Maybe I want to pull that dimension from there to there and then do something based off of that distance. Or maybe it's not.
See if I can hide me. I'm in the way for your screen. Let's
let me pull this out to the middle.
Ah, there we go.
That's better.
Okay. So this face to that vertex is 250 millimeters apart, according to the measure tool. You can create an explicit variable for that measurement, same as you do with the normal variable feature, except now it pulls all the highlighted entities and shows you, okay, here is the minimum distance between those two. But maybe I want the maximum distance between those two, like from that corner to the opposite corner. That's not something that's super easy to try to define in other contexts. But maybe this is useful for maybe like a light simulation, like quote unquote simulation, where you're trying to see like line of sight, what is the distance from this thing to that other thing. Maybe it's for a wiring harness, like this is the absolute minimum value I need to make my cables to run from length to length. You can set up measured variables that when something changes, so say I change this from 250 dimension length to 300, that value now updates. If I change the sketch and then make a huge vibraphone bar, I get the bounding box corner to corner dimension of that.
Cool.
Oh, nice. Thank you so much. And we also have Andrew that says Martin needs someone like this for design requirements.
Yes. Yes. We actually the stream after the design requirement catastrophe day, I started to work a bit more with design requirements. I'm going to work them in slowly, but yeah, I need a Derek for design requirements. True. Okay, so just checking time. We've gone 1 hour of the 3 hours, and we're on topic 3. So I think we should try to go a little surface level to get to everything.
The Z flip issue. This is interesting.
Yeah, we had an issue with that. Absolutely I love seeing you work in Onshape, Derek. It's so inspiring just to see you navigate the tool. How do you feel about moving on to subject 3? Why sketching on mate connector solves the C flip issue?
Yeah. So I set up a demo document for this, and I started to record a video, like I said, that was essentially just a duplication of Evan Reese's work.
Yeah. Let me give some context. When I was moving stuff, I'm gonna actually take over and go to my screen. When I was moving stuff around here in the blob part, I was moving this wheel, the handle of the input crank. I was moving that over to this. It was first here on the left side of the machine, and I moved it over here to the right side in my stream. And the whole thing just broke. This handle flew somewhere else, and the extrudes didn't work. The reason that happens is that often, the way I've sketched it, Onshape didn't know what was up in the sketch. So when I turned this almost 180, it flipped the whole design upside down and broke the design, even though all the sketch lines were constrained. So that is the C-flip issue. And I solved it by redoing the sketch, but Derek is going to solve it in a better way. So over to you, Derek.
All right.
Is there a cat there? Wow, brilliant cameo.
Cat walked across the
Okay.
keyboard.
So, make connectors and planes they have somewhat overlapping utility in Onshape. They're not one-to-one replacements for each other. Although the things that I tend to do with sketches tend to be better done on make connectors, and it brings you some stability that you wouldn't otherwise get. So I have this sample studio set up, and I'll hide some stuff that's not super relevant right now. I'll suppress the triad transform. We'll just go start out on a basic cube. So this sketch is I drew a sketch which has a up arrow and then a right arrow and then a circle centered on the origin and a label centered on the origin to like prove how sketches work in 3D. And when you're doing sketch planes in simple Cartesian coordinates like X, Y, Z, things are pretty stable. It's when you start moving things around or like moving across the origin that things can get a little bit less stable. So if I change the definition face from this cube, like this front face of the cube, and I switch it to the back face of the cube, everything looks the same, right? Except that if I wanted my up arrow to remain, up facing this way on this side, and I just switched to the back side, it, 180 rotated around the whole cube. Now my up is on the left or on the right of my screen and it's backwards. So I'd have to go edit all of these to make this work out. And some of your sketch planes were defined on surfaces of objects rather than being based on planes themselves. So anytime you make a plane, you see how sketch 1 is inverted from like this direction. It looks like it's mirrored. That's telling you that the sketch plane itself it has a normal direction, which is facing towards like Y, the green arrow in the coordinate cube.
I've actually been thinking about that because people joked with me on stream. Oh, so we're sketching backwards and upside down again, are we? Should I care about? Should I have this sketch 1 up into the left? Should I care about where it says that?
So it's just a thing that tells you what the orientation of your studio is, but you should care about it because it defines how all of the things like in your sketch toolbox interact with everything else. So for even the simplest example, if I draw a line and I have that vertical constraint there, vertical means in the sketch oriented in its local coordinate system up or Y direction of the sketch. All planes have their own coordinate systems, their local X, Y, Z, Z being, out of the plane.
Yeah.
And then Y is always vertical and X is always horizontal. So if I go back here and edit this sketch definition and I select a different face and I go from front face of the cube to the top face of the cube, you can see that it preferred the like global Y and the global X to orient itself. And it always centers itself as like a projection around the origin. So if I like select any different planes, if I go instead of the cube, do my polyhedron here, start defining things based on that. If I go grab that top face, then the sketch ends up being located on the top plane of that polyhedron, but the origin is still over here, according to world space. And maybe I don't want that. Maybe I want the origin centered around that pentagon. That's where make connectors can help localize things. But let me show you what happens when things aren't in planar context first. Let me go unsuppress this triad transform.
Yeah, now we're going to see the C-flip issue here, I think.
Yes. So, and I'll use final to like show this off, where if I do this and I do final, you can see that my sketch is here. It's on that front face. And if I start rotating up and over, the sketch is behaving weirdly, where it's like jiggling around, like the arrows are like kind of doing a cha-cha slide thing where they're pointing unexpected angles. And the reason for that is something called gimbal lock, which if you've done anything in programming and you've worked in Euler coordinate systems where angles or rotations of like X, Y, and Z, if you do like a 90-degree offset and then another 90-degree offset about another axis, any change you make to that third axis, it like allows infinite rotation. It resolves indeterminate. So what Onshape does is it automatically grabs the more appropriate axis that isn't going to resolve in gimbal lock. And that means that you don't get any control over it because Onshape themselves are, switching things on you. And you can see if I go over center,
yeah, there it is.
some of the stuff flips upside down.
There's the flip. There's the C flip. Euler, as in Euler the mathematician. Is that Euler coordinates?
Yeah.
Okay. I just tried to say that I knew there wasn't a mathematician on us.
Humble brag.
I don't know what Euler coordinates are. We leave that for this stream. But that's what you just said before, what you just saw 10 seconds ago. That's the C flip issue when sketching on a plane, and Derek provoked it, and I guess we can't provoke it on a mate connector in the same way.
Right, because what mate connectors do that's different from planes is rather than assuming that world coordinates are valid, I can define what the coordinates are supposed to be. I can say center of this, and then I'm actually going to have the Y flipped face down, so my arrows are upside down. But nice thing about mate connectors is that I can do this quick snap rotate 90, and if I wanted to flip this front to back, I can do that.
That's so nice.
And it gets you more control over your sketch definitions. And you can see it's a little bit out of alignment of my cube here as well. Like it's still trying to orient itself world Z or world Y. You can realign this where the primary entity, if you do that selection, it'll align the actual like Z of the plane oriented some direction. We don't want that. We just want the secondary defined. And we'll do that here.
Ooh,
and
nice.
Make that nice and aligned to the cube. And we could also change this so that instead of the origin being on the center, we can change the origin to be up over here. And the same local, secondary entity will move all of the unconstrained things around to meet that. So I'll show that one more time so that it's kind of clear. Right now, the origin label is up and to the right. And if I select this new implicit mate connector over here, all the labels will shift centered around that local coordinate system. Everything in this mate connector's context is going to be centered around that origin on the sketch.
And what happens?
Except you can see.
Sorry. Go ahead.
That circle is not. And the reason it's not is because I define that as that is coincident with the world origin. So I would need to delete that and then make that coincident to the actual mate connector itself.
Okay.
Maybe that picked up the cube, but you get the idea.
Yep. And what happens if you rotate the cube now? Wait. I tried to make a go. The sketch is following the cube. We don't have a C-flip issue. The sketch is just turning the way Derek is turning the cube. If I would have sketched on a mate connector plane, my handle that I showed previously, the handle would not have broken when I moved the gear like 45 degrees.
Boom.
Boom.
Now, I do want to point out some of the positives of planes as well, because there are cases where you would want to use them. And the obvious ones are if you're doing like a 3-point thing, where maybe you wanted to split this cube in half. Right now, the default mate connector feature does not allow you to do 3-point geometry, although you can do that with Constantine's multi-mate connector, I believe.
Of course.
You can switch that to some reference vertex and be able to do a 3-point connector, I believe. Although I tend not to need that specific orientation of things. But one of the benefits, aside from being able to do 3-point planes, is some features like intersection curve operate on like surfaces, and mate connectors don't technically count as a surface, but planes do. So you can do an intersection curve between the plane and the part itself. Another feature that operates that way is like the enclosed feature. So if you're doing surface geometry and you want to do like a bunch of surfaces and then cap things off with a plane, that works with planes, but not mate connectors for the same reason. These actually do get treated as surfaces, where mate connectors don't. So there might be times where planes are preferable, but usually when it comes to sketches, I'm almost never reaching for planes when I could use mate connectors instead.
I watched Evan Reese's video that you sent me. We linked it in a previous stream on mate connectors, and just 5 minutes into that video, I never sketched on a plane after that again. So I feel like a smug Onshape user that only sketches on mate connectors. That's really, really fantastic, Derek, because the C-flip issue made me feel that I wasn't in control over my CAD, and I couldn't see what I was doing wrong. I had all the lines constrained, and still it didn't work. But this explains perfectly why sketching on mate connectors is overpowered. So thank you so much for showing us that. All right. Should we go to the next one, Derek?
I think so. We kind of touched on this as well with the vibraphone, like where to duplicate subassemblies.
I'm thinking perhaps it's perhaps it's not so interesting, number 4, or what do you say? Or is it? Perhaps it is.
Well, it is to some extent, where sometimes if you're working on projects that maybe you're working on something that isn't an individual project. Maybe you're working for a company and you're doing, shared subassemblies that you're going to reuse a ton of times. Something like a vibraphone dropper, where this might not go into Marble Machine V1 only. It might go into V2, V3, V4. Setting those up as external libraries is an interesting topic, but maybe a little out of scope of what we're doing now.
So the topic we're discussing is where to duplicate sub-assemblies when we need many instances. So you can just tell me basically, or I can switch to my, if we remove the graphics, all these placeholder marble gates.
Mm-hmm.
So I did the marbles just for visuals. Perhaps I wouldn't even have the marbles in there, but all these wheels and these droppers, what would the structure be? Where do I duplicate them? Do I duplicate them in a sub-assembly, or do I duplicate them probably not in the master assembly? Do I draw this in one part studio and then, tell me.
Okay, so let me switch over to the same tab you had. We had...
I'm in the master assembly there.
Well, I was looking for like this kind of thing, where you have all these individual gates.
And for everyone, this is just symbolic CAD here. It's not. I'm
saving your ass.
Yeah, I don't think that design would work. So don't ask me. Okay.
But something like this, like on the level of complexity of like the marble gates themselves, where you have a ball track that comes through here, you have the spirit fingers. And you have whatever escape and wheel mechanism happens to go into the final thing. There's enough complexity that goes into just one of those that you don't want to pay the full performance penalty of doing a linear pattern in a single part studio. This one here is pretty lightweight because there's nothing in it yet. But when you start adding, little retainer features or fasteners, or you start working in sheet metal, where sheet metal just gets expensive because of how it works, you don't want to have duplication of these parts all in the same spot from the start. Similar to what we're talking about with the vibraphone resonators, you want to set those up as some kind of configurable document and then pull them in either to a subassembly themselves, if you want to like manually mate all the things together. And like I showed off a little bit, it's going to have to be, these are different because they have, it's not every single one is unique. You have sets of these that are going to be similar or the same.
Some are 40mm marbles, and they won't be on a linear pattern also. They will be on on specific drop points. So they will be, I guess, mated to mate connectors on specific points. Some are 30mm marbles, some are 20. So I have a set of different designs. So
Okay. Well, in that case, if it's not able to be expressed in an assembly with a linear pattern, I think we're gonna skip topic 5 and come back to it, and we're gonna just go into Amalgamate and explain a little bit about what that is.
okay, let's go back to the graphic so I can give context. We're gonna jump to topic 6. What is Amalgamate and why is it awesome? This is a custom feature that Derek has built. So over to you, Derek. This is the Amalgamate awesomeness.
Okay, so to explain Amalgamate, I should probably start by showing a derived workflow that isn't like the blob context. You're gonna know about derives because that's how we got all the part studios set up to like do individual broken down substructures of design context. But if you instead of drawing a master model, if you instead set up a part studio, you can pull this part studio into any other part studio, just like you did the master assembly. But this is actually a functional part or near enough functional part. And you can insert those into another document. And if you do multiple locations of derive, you get this fun message where it says using derive feature to make instances is not recommended. Consider using an assembly instead. That's the devs telling you you're about to make what they consider to be a mistake. I consider it to be an optimization, and I ignore that message. And we could do that. We can insert all of these derived gears, and the performance is lesser because anytime you do a derive feature, it pulls the entire studio in as it does the whole rebuild, unless you could set this to a version, and this is why I talked about this at the top of the stream. If you set this to a version of V2, it's not pulling the live version of the document, it's pulling the one that was saved. And before it was like a 2.7 second rebuild, and if I wait for that to update and then do a Control-Shift-R to reload the tab, sometimes it likes to gaslight me. It might be going out to the server to go fetch the document. But I'll wait for that to build. It does perform faster.
So can I ask you
that, roll back up.
Can I ask you why? Because I haven't gone to the point where my document, where my CAD becomes bogged down by performance. Why are you so focused on performance? What's the future issues?
Trust me, you'll get there.
No, okay.
But the issue is that when you start doing big part studios that have a lot of marble gates, which I'm going to show you an example of like why you should do that, performance is going to be the deciding factor of like whether you're going to be able to do things in your document or whether it's going to be bogged down and you're going to hate life and want to go switch to a different project. So you always have to keep it in mind, and it shouldn't fully dictate your workflow, but it should inform it, is what it comes down to.
So basically, as a if you're not looking at performance, it might look on the screen, oh look, the vibraphone looks great, but I did it in a way that is just expensive performance-wise, and probably some other workflow can be 1,000 times less intensive for the CPU. Is that it, or what's the performance? Is it CPU? What is it? I don't know how computer works.
It's really, I mean, these are actually CPU. Onshape runs single-threaded on a server somewhere in one of the Amazon web server blades in the world, whichever one depends on where you're at. But it is single-threaded performance. It is a CPU, so it takes time to crunch through all of the instructions in your document. And really, it's not the computer's performance you're worried about. It's your performance. Build time in a part studio, and then you add a new extrude to that document, you're going to wait 15 seconds for that entire part studio to reload as you just sit there waiting for a hold to appear, or maybe the hold isn't where you want.
Yep.
So as parts get more mature and things get, longer winded, projects are towards their quote unquote final stages, and then you're like 30% of the way through and just waiting on document performance. You gotta like always keep in mind what the regen time of your document is.
Yes.
So
I got there in Fusion 360, so I just didn't CAD that many things in Onshape so to get me there. Yes, but go ahead. Amalgamate.
So the derive workflow, when you set things to particular versions of documents, instead of being a 2.7-second performance for this document just to bring the gears in, now that I set it to a version, because it's cached and it's set to the server, it knows what that part is. It's no longer trying to solve the entire feature tree. It's able to do all these gears in 452 milliseconds. And if you look at these gears, they have full involute like gear teeth geometry on them. I did set up a document that was like pretty, maybe not like full CAD, but like closer to CAD, ready for production. So these are finished parts, and I got there in 2 features. So derive workflows are powerful. Amalgamate takes derive workflows a step further. And the way it does so is derive features themselves only have the option to insert geometry. They don't have the option to do additive geometry or removing geometry. So what I set up with this custom feature was I made it so that you can predefine geometric operations. So if I open up my custom studio here, I have, you know, whole gear feature tree, sketch extrude, custom gear feature, some things that I'll talk about in a second. But all I'm doing here is I'm doing a tag of the body that I'm going to insert, and that's going to be part 1. There I go, not naming things. Part 1 is going to get inserted into this other document when I go to call this feature. And you could do more than just additive geometry. If I were to like do a cylinder here, and we'll hide some sketch here to show this off.
Shift P hides everything. Am I right?
Do you know how good you are?
We'll do a cylinder extrude, and we'll just pretend like this nub here. We'll do a new, pretend like this is a shaft. We'll do blind 25 millimeters, and we'll do second end position up the top face. Go up here. There's my shaft. And I will do a transform copy of that shaft, and I'm going to do copy in place, and we'll hide the other stuff. I'm going to do move face. I'm going to say that I want a clearance of 1 millimeter around this shaft. It's an aggressive clearance. It's not real, but it will be able to be seen on camera, so that's why. And I'll start naming some things. We'll do...
So this is what you would use for tolerances.
Yeah.
Yeah.
So cutting tool, shaft, and then gear. And then we'll go move my tagging system down here and show everything again. Okay, so, and maybe I'll do a Boolean on the gear itself to show... We're going to cut the shaft away from the gear, and you can also set offsets, by the way, for clearances in the Boolean tool if you have used that or haven't used that yet. If you wanted to do like a 0.2 millimeter clearance around things, like all around, there's one way to do so. So I guess I'll do that now. And then I'm going to set this up so that we have a part to insert the gear. The shaft disappeared because I consumed it here. I want to keep that tool. So we're going to insert the gear, we're going to insert the shaft, and then we're going to use this cutting tool as a subtraction operation. And you can see that it turned purple and like kind of transparent. That's so you can see through stuff and see what your actual insertion parts are. And then if you have union parts, you can do those as well. So this is like predefining the geometric steps that you would do for wherever this gear is going to mate. So now that I go switch back over to this deriving on weird example or weird angles example, I had already set up a bunch of amalgam insertions. So this should rebuild and then cut away all of the like shaft holes on things.
Oh, wait. Okay, sorry, I was confused. I thought your Star Wars, the Death Star here, was the origin document. This is the origin document here. So what we're looking at now is the start of everything.
Right. This is the like seed definition of the like gear amalgam,
Okay.
and I'll go ahead and call it that.
Yeah. Okay, now I got it. I thought it was the other way around, but and then the cool this one that we're gonna look at. It's visualization of the resulting CAD.
Right.
Okay, now I'm with you. I thought it was the other way around. Okay, now it was like I was a little bit hard for me to see where it was going, but now I see it.
And my amalgam feature failed because I didn't have subtraction steps defined before, and I need those. So it didn't know that I wanted to subtract something because before I didn't ask it to. So if I do set that up now, this first configurable gear amalgam is going to go pull itself in somewhere around here. Those 3 steps. And I defined this part 1. Now everything is part 1, so let me go fix that. Just the Death Star. So now if I go zoom in on all this, you can see the shafts came in. That may not be surprising, but if I hide these, that hole also generated, where if I section view one of these, all of the clearances for that geometry are pre-applied. And it goes further than that as well, because if you do
which would be on which could be changing then the clearance of a whole project, right? That's what you're getting at. So
right, like if I change this shaft clearance and like, oh wow, we just messed that up. Everything should have been, instead of 1 millimeter, we have really bad stock. We need 2 millimeters clearance on these parts.
Yeah.
Switching back over here, everything being centrally controlled, it updates everywhere this gear is used.
Yeah. So if you use it 20 times all over the machine, it would update everywhere.
Mm-hmm.
Okay. Sorry for interrupting you. I just wanted to make that point there.
Well, I should also probably show this off. It's automatically updating when things are in the same document. But the downside of that is the performance of Amalgamate. If it's in the same document, this is a 4-second rebuild on this because it's referencing the live version. We're going to go ahead and set that up so that instead of doing the live version, it goes to V2, which I didn't have cutting geometry there, so that's going to break. But we're going to go ahead and create a new version so that that's not the case.
So for the marble machine, while you're doing that, can you explain, like, probably I can use this on a lot of stuff? Or is it like, do you think I can use this kind of everywhere? Or did you have a specific use case in mind for my project?
So it is kind of an everything feature. I mean, the gears are the obvious thing. You're going to be doing so many different sets of gears of different sizes. You're probably going to be changing from like size to size. And I suppose I should show that as well after this. But the ability to source control all of your repetitive parts using a like central library of these individual documents, like this configurable gear can live top level outside of your marble machine workspace. You just make a new document that contains the gear. And then anytime you make changes to the gear, it propagates all over the place. So I also think this is a solution for the marble gates, potentially the marble funnels, funnels 2, where each one of these would come in as an amalgam like individually. So you would have to do like a placement there and then there and then there, and you'd have to do like 15 amalgams or how many there are of these. Although I think query pattern might be a solution to that as well, where you can vary the individual instances based off of geometry. That might take some more explanation and like exploration on my part to show you how that specifically would work. But I was prepared to show the gear example. this setup right here, where I have those configuration variables, where the wheel diameter, I can switch this from 200 millimeters to 500, and everything should update here. The same thing applies in the Amalgam Studios, where I'm doing my imports. Let me turn off section view and show off one of these. So let's say top face of one of these gears, or wherever this make connector is. This make connector, that one there. We'll do the subtraction scope, so we have that there. If I wanted to change this from a 200 millimeter gear to a 400 millimeter one, then that can update over there. If I wanted to change this from 6 spokes to 8 spokes, then that updates over there.
Okay. I'm not following exactly, but I don't have to follow. I see just the possibilities are really, really inspiring. So it always takes some time for things to click like exactly for me, but I see the possibilities here are endless. And I think you built Amalgamate for like for purchased parts, like the size of a bolt, stuff like that, and that's a geometry that you reuse 100 times on a project, like the same bolt hole or
that is how it started, where it was like a bearings feature where we would, why are you going to draw the same bolt pattern for an ANSI bolt flange bearing 50 times? It's the same bolt pattern, just imported every time you use that part. So that's one reason that we started using it, but we found out that by doing custom sub-assemblies and then inserting them, even if you're using them once, you can avoid the whole in-context workflow, and you can avoid the limitations with assembly patterning right now. You can get around them by doing things like this, where, this should, according to Onshape's own guidelines, be an assembly. Yeah. But because the performance of versioned amalgams is better than the time that it would take you to go build the stuff in an assembly, you actually get through projects faster using this stuff.
Wow.
In the MarbleGate or like funnel example, to apply this back to the marble machine, probably what you would be doing is you'd focus in this entire document down to just one individual seed unit, like hide all of this stuff. And you'd build like one really solid version of what this part is and does, and make it so that that one studio is configurable so that it works with the 12 mil marbles. If you needed 18 millimeter marbles, 40 millimeter marbles, you're doing all of your control in one single part studio. And then when things need to be placed on random coordinate planes, you said that these are going to be positioned over droppers, and those positions are not going to be a straightforward pattern.
No.
What you would do is draw the studio where you're defining all those pattern points, and then just bring these guys in on top of them, if that makes sense.
Yes. Wow, that's fantastic. I've been thinking that makes a lot of sense, because of course the 18 millimeter marble gate for 18 millimeter marble is going to look a lot like the 20 millimeter marble gate. So it can be the same, but to have it configurable, that sounds absolutely fantastic. I won't be able to go to that workflow tomorrow, but you showing me this now knows kind of where I'm going, like in a couple of weeks, I guess.
Yeah, if I'm going to give you homework, it would be to practice working in one individual studio and then working on using these configuration variables to make things change like individually, because that plays directly into the rest of the Amalgamate workflow when I set up other demos to show you more how that should integrate back into the final build.
Derek, can you say that again? The homework, my ears pricked up. That sounded really nice. So one part studio. That's kind of what I do, but try to be in the part studio and then do the configuration.
One single part studio, one gate. So not all the gates, just a single configurable gate, and then make that work so that as you change configuration variables. So we'll go ahead and add one of these in here. Marble size, is one of the variables. that you'd be using for the gates. And what sizes are your marbles? Are they 12 mil to 40 mil?
The smallest. Between 10 and 40.
Is there a default for the machine?
Let's go for 20.
All right, so I'm only going to do the one because it'll probably drive everything else. And Evan Reese does have a video on doing configuration variables for... actually, that pillar organizer video may not be live anymore. We'll follow up later if we need to. But these spheres, whichever the seed sphere is, somewhere in here, you could set up dimensions that control the size of those and then set up all of the rest of these ratios so that they're built on that single configuration variable. So we're going to go ahead and change this one value here. Now, this should only update the marble size, but I don't know.
That's not the marble sketch, but that's the wheel sketch, but...
Okay. Which one's the marble?
Yeah, I didn't name because this is only ugly sketching.
There it is.
There it is. So now you go in and you write the variable, and then that's configurable. Okay, yep. That's so cool.
So I'm just going to hide everything else because it'll probably break, and we're just going to see the sketch update. But if I change this from 20 millimeters to 30 millimeters, then it should only update that sphere and maybe shift things around.
Yeah.
It wasn't too bad.
And then I can base the width of the marble lanes, and everything should follow yeah, and then of course there will be some distinctions, like in the bigger one. The bigger ones are maybe not going to be exactly the same design. It's a little bit different. It's just not beefing everything up like with a multiplication. But that's really cool, like, Eric. I love that.
Changing to like sheet metal thickness, maybe. Yeah. You can set up like expressions for those as well. That is a deeper topic than we'll get into today. But you can set these things up like very parametrically so that you have full control over like one piece of generative geometry. And then you can plug that into every location where it's relevant faster than an assembly workflow using Amalgamate is kind of what the workflow has evolved to for us.
That's fantastic. But do you agree that I can, like, before I even know how to build the part, or even when I'm so early as I am now in some stuff, that I can kind of, for me, it's hard to simultaneously figure out like what the part should do and also do it like in super good CAD structure. But the homework that I should start with is a little bit with configurations that I can do already now on this messy early sketching.
Yep.
Okay, perfect. And Amalgamate, everyone can use it. It's just to download the custom feature. So all the Onshape users watching this, you can go and try Amalgamate already now.
If you're watching this and you're curious about how to add custom features and miss the other stream, one of the ways to do that is to like click the feature dialog over here, top right, do plus add custom features, and then go, if you know the name of the feature, you can just type it right in. And filter down to the Variable Studio icon. Amalgamate 2 is not a real thing, and I don't know why that's there, and that's why I don't recommend this typically. But the other way that I post all of my features to the forums. So if you go here and type in Amalgamate, here's my discussion thread and the link back to the original document. You can click through here and go straight to the actual Amalgamate feature. And then once you're on this page, the custom features like plus icon, assuming you're on the version and not the live tab, you can click the plus button and it'll add it to your toolbar. It's already added for me, so these are already on there, but I can remove them, add them. That's how you get custom features, either through the search window, which is a little bit clunky, and I have people at Onshape looking into fixing that.
That's great. That's great. So Can you give us, before we move on to the next subject, Derek? Can you give us a summary, like the what do you say, the 1,000 feet image of what Amalgamate is and what it does and why we should use it? I know it's hard, but can you just summarize again, like what it is?
So at the simplest form, it is a way to do central control of your geometry, either project-wide or company-wide, and give you a single point of reusable geometry, and not just as an insertion feature, but as a tooling geometry database where you can add and remove material from your parts without having to go and replicate those steps manually, where manual reapplication of those same features would result in human error or just extra time in the document where I'm drawing the same wheel sketch for the 16th time, and I know these steps, and we're just going to sit here and do the same 16 steps over and over. And it's not just useful for purchase parts, it's useful for all shared custom assemblies as well. Anything that you want to not have to do a second time, Amalgamate is there to do that.
Fantastic. All right.
Big
Hannes.
time saver.
Yeah.
I have a question from Ludwig, really fast here for Derek. Speaking of bolts, Derek, tell me why you should use hole feature and not sketch holes. Asking for a friend who's wearing a cap in the bottom right corner.
Okay, so
That seems important.
Yeah, let's show a little bit about this. This is a newer feature. Well, hole is ancient, but I'll show it in application via some of the newer options here. So I did a sketch here for the shaft, and I did a clearance around that had a particular dimension. But let's pretend like I'm not mounting this on a shaft. Let's pretend like I'm just going to mount this on some standard hardware. I'll roll back above this whole sketch feature, and we'll go draw a hole.
With the whole feature, not with a sketch and a circle.
With the whole feature.
With the whole feature.
So Onshape has done a lot of legwork towards making their whole feature have standard dimensions and notations for things. So they have all the clearance holes for all of the M5 fastener library or metric fasteners. I guess we are on US streaming time, so I should show that as well. I don't know what the clearance size is for, let's say, a 5/8 bit of hardware. And this document's in metric, of course. Mixed units. For the US audience, I don't know the clearance size for a 5/8 hole. I've never needed to know that, but I have needed to notate that on drawings. And there are ASME standards baked in to the actual hole feature itself. You don't have to go look those up. You can just go select that and then go do the point. And then that hole is a clearance hole for a 5/8 bit of hardware according to that standard. Maybe it's not a normal tolerance. Maybe I want to do a close tolerance because it's a precision part. Maybe it's a loose tolerance because I'm going to go at this with an angle grinder later. That is all controlled by these fastener fits.
Yeah. Okay, and also you prefer using features over sketches, which is actually a point that we're going to go into later. So what do you think Ludwig is hinting at when he's trying to bullying me around this making holes with sketches, apart from those features that you showed there?
So number one is just the consistency of having the clearance is all baked for you. But the other thing that you might notice on the screen here is that this whole feature shows that it's a 0.688 through. I'm going to switch back to metric just for the sake of the other side of the audience. US had their time. I'll go back over here.
Perfect.
And apparently the clearance for an M22 is 23 millimeters. Wouldn't have known that. Okay, it's different for a normal fit. Man, metric system is just so nice.
Yes.
But let's say you're doing a tapped hole, and maybe you want to switch fastener size from coarse to fine or whatever, and all of those geometries switch. You see all these annotations are updating here. Now, I don't know that your CAM software is going to be able to read these, but some CAM softwares read these. And if your software is capable of reading these annotations on these parts, that should update here.
I get it. It's the proper way of doing it, and then you can probably go back and just say, oh, all of these holes should be this now instead. It's just a feature built for holes instead of just using Sketch.
Right. The other thing is you can switch these to like counterbore and countersync at whim if you wanted to, where that's actually just not possible with sketches. You can't do a countersync geometry, and I guess that leads us back to like hooking back into step 5 or topic 5, why I hate sketches and why you should too.
Perfect. Should we give Hannes? Do you want some airtime, Hannes, or do you have something
Chat
from
is
chat?
so quiet. I think they're listening to everything Derek says. They're so intrigued.
Perfect.
They're just saying that it's so nice to learn, and I don't have any actual questions right now. They listen to our advice that I will collect questions.
Perfect.
Yes.
Or Amalgamate put them to sleep.
No, they're still here. Believe me.
So now our hyperbole subject is up. One of the things when I started talking to Derek that he couldn't contain himself was his hate for sketches and his love for features. So I don't know if it's because I came from Fusion 360. I took pride in making the feature tree or the timeline short, which meant that if I wanted a fillet in an inside corner, I wanted to add the fillet in the sketch as well. And I think that's a good example where Derek told me very early in our conversations that add the fillet as a feature after the extrude instead. And this changing the sketch goes faster if you don't have fillets in the sketch. I think that could be a good example, Derek. Perhaps I should show it. Just is that a good starting off point?
I think so.
Yeah.
I could set up some stuff while you're showing that.
So I'm going to go into a new part studio and I'm going to do a sketch, and then when I sketch the frame, I sketch like this, a frame here. And then I want this fillet here, so I add it here in the sketch. I think I'm super cool because I can hit T and make that tangential. And when I extrude my part, boom, 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 we have a beautiful fillet here. And look on my super clean feature tree here. It's only 2 features. What Derek wants me to do, and what I don't know why, but he's going to tell us right away, is Derek doesn't want me to do this. He wants me to coincident these 2 lines and extrude it like this. Hit Shift F and add the fillet as a feature. Let's see if this works now on both edges. Something like that. So now we have the same result, but we have bloat in my eyes. We have bloat in the feature tree, and I think perhaps it's a little bit like with the whole feature. This didn't end up perhaps correct, but anyway, the fillet can do more stuff, of course, than a sketch line. But I think over to Derek. This is a question. Why adding the fillet as a feature and not in the sketch, right?
So I'll hide the first example over here because actually I did this in an inverted order. Let's say we're going to do a frame, something like the frame geometry on the marble machine. This is a simple square, but I did a construction line, 2 offsets equal on either side. You could set those up with variables, but we're just going to do this as is. I can take this part and extrude it, and it will have, nice thin frame geometry where it is what you'd expect, rectangular frame. But now let's say that I actually wanted to add fillets to the inside of this frame, and I now go back into the sketch, and I have to go add those, not too hard. We're going to go add fillet there, add fillet there, add fillet there, add fillet there. Increase the size, whatever. and it does build. It's stable software. It'll do that. But now let's say it's not a rectangle. Let's say I wanted to do a hexagon frame. Just squares, not feeling it. I want hexagons.
Of course.
I would have to go back in here and then essentially delete this whole sketch and do my hexagon build and then start applying all of those like offsets. I have to like set that to a construction line geometry in here. Gonna select all those, turn them into construction, and do a offset from side to side.
Is there a command where you offset symmetrically one sketch line in two ways? Or do I always have to offset twice if I want?
You'll be surprised to know that no, there isn't, and that's one of the reasons that I don't do this very often.
That's a nice feature. That would be so nice.
And a lesson in sketch stability here. This sketch, if I hide the extrude and just show the sketch, I didn't make that midline construction, so I have this region highlighted, but I also have this region highlighted and this region highlighted. Onshape doesn't know what to do with that information with the inside profile here. Like, am I supposed to do that extrude and then that extrude? Or am I supposed to do only that one? So what it does, if I do faces of sketch 2, is it's going to go walk that border and it's going to go, okay, I've found a region. I'm going to go extrude that one. And then if something is like indeterminate in here, it'll skip it. So it forces you to use construction geometry more when you're doing your offsets in sketches. So I have to go back here, go edit this, and then turn all of these into construction. And do that. And then I have a single valid region now, so my extrude does build, but now I have to go back, edit the sketch one more time, and add my fillets in. It's a whole thing.
Yep.
Or we just don't do that. We delete all this. We'll do inscribe polygon. We'll do another hexagon. And change this to thin extrude. You saw that earlier. We'll do midplane and do that. And now I get the same geometry, only having to do one line.
Fantastic.
20 millimeter thickness, I think, is what we did. And I could do my fillets after the fact.
Right click, select equal length. I've learned hard.
Yeah, you could do that, or
better,
the one other type of variable, query variables.
Ooh, so it searches for stuff.
Yep.
What?
Mind blown.
I'm some kind of crazy world here now, Hannes.
Is this a dream?
Derek, you have some kind of jitter on your screen share. I wanted to wait until because you're now just going to give us the slam dunk of your whole point, but the jitter is starting to be a little bit. I feel for Gonsonator, his headache is going to come back.
Let's see if I stop sharing and reshare.
Yeah, try that. We can go to my
Switch to yours.
We can
and
switch
while
to mine.
you do that, I just want to. I have some chat feedback for now about.
Sleeping from
Yeah. No. We're here. Ears open. We're so focused. We're drooling from all the new info. This is an amazing learning chance for us all. Can talk, learning.
Oh, wonderful.
And then we also had a donation from our dear friend Martin. Idea. Whenever Martin clears a major milestone, Martin should invite Derek for brutally honest review.
That's a perfect idea. If Derek's up for it, I'm up for it. That's a great
Come back
idea.
and delete another tab.
Yeah. I think your screen looks better now, Derek. Thanks for fixing that.
Okay, cool. So we're probably going to need to do a couple of mixed features, but you could do
sorry, Derek, the frame rate is now back to the original frame rate. So let's go back to my frame rate and you update the frame rate again. I can spin this around with nice frame rate and play music at the same time.
Oh, thanks, Ludwig.
So yeah, sorry for. Oh, that looks perfect, Derek. Okay. So now you set up a query variable.
So what query variables are is queries in Onshape are like the boxes that you insert things into. So if I do an extrude, this edges of sketch 2, that's what's called a query. It's a selection set of something. Could be surfaces, could be edges, could be vertexes. So one of the types in Onshape. Query variables then are variables that contain queries. So in this case, I'm doing a created by query variable. So it's a query of edges, in this case, created by extrude 2. So that's all of the edges that extrude operation made. I could further filter that for construction entities, which is for like sketch or planes. If you had surfaces, I referred to planes earlier, count as surfaces. But if you don't want those as part of your feature, you can filter those out using that option. And there are a lot of these other options in here that are like not entirely relevant to the current example, but you can select edges created by that extrude. And if I wanted to fillet all of these, it's as simple as go into the fillet feature and this new icon shows up for a little search magnifying glass. I can input this inside corners, which right now is not inside, it's just every corner of this. And if I wanted to fillet all corners of that at 5 millimeters, that'll let me do so without having to touch the sketch at all. But I don't want to do these outside ones here, so we have to further filter this. So actually, I'm not going to do inside corners. This is technically all corners. I can make another query variable. This is inside corners. And I can do edge convexity, and there are different types of query variables. Some of them are like selection sets. Some of them are like more like filters. This is more of a filter type of query where it's looking for edges that are convex or not convex. So of all corners, if I'm looking for only the concave ones, that should work. Why is it not working? Evaluate on use.
So query variables is kind of like what to select variables, right? Okay, I start to understand it. So, but that one failed the concave.
Oh, okay. This I misunderstood the selection set here. This is, you don't need to do the filtering on this one. This actually will just find all of the concave edges on a part. So you can select the part and then go all of the ones that are inside. We're going to go ahead and fillet those. And we'll change that to be inside corners instead.
Oh,
so
cool.
I can get rid of this because we're not using it.
Cool. Can I ask
now
you,
if I go back,
is this Part Studio specific, or is this document like this query variable? Is this for this Part Studio only?
So query variables are Part Studio specific, and you can't pass them between studios. But if you use Query Variable Plus, I have this other option here that says Save for Derived Studios. This is another me feature where if I wanted to go save a selection set, we're just going to go do this top face, for example, or front face, whatever. I'm going to save that selection and pretend like this is a blob studio, and we're going to go derive this guy into another derive this blob into another part tab. And we'll just use the default derived. We don't need anything special.
Just a plain old cookie cutter derive.
Hey, sometimes it's not all about the custom features. Sometimes the basics get the job done.
Coming from you, that's a lot.
All right, so I made sure that I had a name for this variable. I made sure that I had the selection. I don't need to necessarily show the selection. It's useful for diagnostics, but drawing this geometry does cost some amount of performance. So it's useful for like seeing what you're setting up. But once you know that the selection is correct, or for like debugging, you should turn this off to not have that performance penalty. So we're going to save that selection. And over here in Part Studio 1, where we derived it, that if I were to do a like a move face, there's no icon here to select the thing from the query variable because the variable didn't pull in. What QV Plus does is it allows me to use many more query options. Like Q adjacent isn't in the default set. You can't find adjacent entities with normal query variables. You can with my version of the feature. You can also do like matching bodies or like a bunch of other stuff, but the very bottom has this load from derived feature. So this doesn't actually get a normal name. I should take that field out, but I haven't yet. All this does is it loads every QV that existed in that studio that I pulled in. So you can see here it has the front face defined. So now if I were to do a move face on the blob, it lets me do so.
Cool. Can I ask you a specific just about this query? How do I pronounce that? Query variable. If I go to my screen, something that I've been fighting with, if I just take any gear here with some spokes, is that I want different fillet size. If we roll back before the fillets, so I want to have a larger fillet on these corners than what I want to have in here. So if you see here, I have two fillet features. How would you define like now there's not a lot of edges, but sometimes I wanted to add the fillets after having all the spokes, and then there's a lot of clicking around all this. How would you set up? Is it possible to set up a QV to choose these edges but not these, because they're the same length? So I can't right click and select equal length because that chooses too much. Like this is very specific, but is it possible to filter for only these somehow? You can say no. It's okay to say no also. Even if I know you hate saying no.
No, I think there is.
Okay.
Let's go show off QV Plus for a second because I have that. And the way I did it, by the way, I did the inverse of what your logic was from the spoke generation. I did a single spoke and then patterned that instead of doing the two halves and split. The reason I did that, by the way, was so that
was
if
that
I
a
little
dig to my CAD practice? Just a small little dig was in there. I just don't want the audience to miss it.
Clever man.
It works, but it's not how I would have done it. It's not how I did it. But I did it this way so that I could do the shaped spokes.
I feel so stupid. Wait. Why have I been sketching? Why have I been?
No, it's fine.
Back to my screen. Why have I been doing that? Actually, I think it was because when I learned how to, it's a Fusion 360 remnant. I should just do one spoke and do that 6 times. Oh, okay. Thank you, Derek. I don't know why I'm stuck in that old way of doing it. It's funny.
And yeah, that's a single line. So if I don't like that profile, I can just come back here and edit that and just bring that in and make it beautiful. A little bit more.
Okay, for the viewers, I think it's important to dig down into the lessons Derek are sharing.
Your stupidity.
Yeah. So over to me. Keep that. Show you doing that single line there. Just changing that single line, and I show you how I did it 2 days ago, in comparison. So there.
We'll go like real zigzag.
Yeah, and then over to me. I did for the flywheel. Someone suggested we should have curved spokes, so I have 1, 2, 3 times 5. I have 15 lines, and I have 2 offsets, and I have 2 actually. But this was actually during stream, like bad cat. I have all this stuff, and if I want to change this, I can't pull this. I have to go for this one, and this happens. So that's a perfect example. That was okay. Let's do 530. It's but this is still breaking, so it's a perfect example. I have 15 lines that break. Derek has 1 line.
That
Okay.
works.
And this is also ties into the topic that Derek hates sketches. Whatever he can do to reduce sketch lines, and probably what I start to see a little bit why, because that makes just the workflow faster and more easier to iterate on, right?
Yep.
Yep.
And then I have like my sketch doesn't have any fillets in it. Like that line intersects with these parts at some border, and like changing that from a straight line to a spline, I would have had to set up new tangent mates and everything in there.
Yeah.
But with the magic of query variables, I just have this selection set, which is those edges there and those edges there, which are the edges created from extrude. And that's a very specific thing. So let me show you what the extrude actually is. If I do new, it shows you the body that's generated. This blue guy from inside out to the spoke here, it does overlap. This angle could probably show, it might miss if I were to change this geometry too much, but here it's stable.
Derek stuff breaks too. That's what he just said. I just want that in to the record.
It does. I mean, I know everything I know because I've broken it 100 times first.
That's nice to hear. Appreciate that.
Yeah, sometimes I tell my team, like, when I'm working on something and I see them doing something that I would consider to be a stupid idea, I'm like, I want you to know that that's a stupid idea, not because it's your idea, but because I had that idea and it was stupid when I did it.
That's you're a great teacher with a big heart, Derek. That's a fantastic way to put it. Okay, I'm not gonna derail you now anymore. Now you can show the thing.
So this extrude operation is doing a new body. I had it set to add so that it merges with the hub and it merges with the outside spokes. And that creates no new solid because it's merging with that original hub. So there's no new edges being generated on the outside or inside. But these new edges here, like those ones, do show up. They're new to this part. And query variable plus lets me do a query of non-cap entities, and I could explain more what that is. Cap entities are the top and bottom faces of any extrude or thicken or sweep operation. So we're looking for specifically the ones that aren't caps, and we're looking for edges created by extrude 3. That pulls me these guys here and those guys there for filleting. Your logic of selection set might vary based on what your particulars of like feature stack are,
Yeah.
but you can often query for things using certain available functions in here.
Could you try to
But-
filter out the inner ones?
That's what I'm about to do.
Okay.
So we're going to do a selection, the additional queries here. I'm going to do an add query, and we're going to subtract all of the edge adjacent edges here. So those it's hard to see because they're yellow. I wish they would have chose a different color for that, like purple.
You
But
you
if
chose
I-
the face there, and all the lines adjacent to that face that you chose, they're going to exclude those.
Yep.
Okay.
And they disappear. And now if I go to the fillet, those edges from there are now filleted. These ones over here aren't. I could set up the inverse of that where I do the
Just
same.
to play devil's advocate, if you would had, of course, you're going to circular pattern this later in the feature tree, but if you would have already 6 spokes, then you need to still click like 6 faces to delete those.
You would have to, and there's a lesson there about like doing pattern geometry. You want to try to do like single segments of something before patterning it, and like putting all your features in first before doing your pattern. So something as repetitious as this doesn't require extra manual selection later. Query variables can help with that, where there are some like spatial variables that you can set up where I have instead of specifically adjacent faces, you can do size comparison or like directional queries. They're like the nearest ones to. There are ways to do more advanced queries that are probably hard to wrap your head around,
Yeah.
and maybe a mistake, honestly, from like a certain point of view. If you have to construct a like 20 variable long query, you're probably doing something either hyper advanced that requires it, or you haven't thought about the problem hard enough.
Okay, so one very basic lesson there is to keep your features in the correct order, and I think this was fantastic. I had no clue this existed inside Onshape, the query variables, but perhaps in the interest of time, we should look over our subject list and see, because we have the blobmania point left, which is going to be really interesting. So we did the amalgamate, and yeah, I really want to get to both 7 and 8 because these are very fundamental, I feel. So number 7 is understanding and working with context, what geometry to use and not use. I got myself into a situation where I all of a sudden created 2 contexts. I don't think I have it here so I can show it, but should we do the context one, Derek?
Yeah, I mean, there are pitfalls there that are definitely worth talking about, and 2 contexts is like the main one, where the rule of thumb is you only want to have a single context per part or part studio inserted into an assembly. So if you have, say, one of those wheels where you needed to like pass a shaft dimension or something through, probably you should do that in other means, but let's say that was just how you had it set up, and you create a context to get that reference for whatever operation you needed, and then you do a second thing and create another new context. Probably the relative position between those objects didn't change, or generally they don't. Like, you have that gear in a position, it's going to stay in that position. Maybe it rotates, but maybe that's not super relevant. The only reason you want to do a second context in the same assembly is if you had like end stops where maybe one of these arms rotates to a position.
Should we just give the context about this context subject?
The context.
Yeah. So I'm trying to remember where I actually created a context, but when I'm in the okay, I'm gonna go to the master assembly, I think, and see. But then I'm gonna okay. So this kick drum, I'm gonna right click it. And then I have the option to edit in context. Perhaps this is not the same. So that's good we're clearing that up then. Because right now, this is going to be a question for you, Derek. Right now, the only thing that happens now is that we get some visual aids here. We're seeing the whole assembly while I can slide while only working on the kick drum. So I can go in and change the design of the kick drum according to how it fits in the main assembly. But I guess if I would do a sketch now on the face of the drum, this is a little sluggish here, probably because I have the whole master assembly taken in here. Oh, sorry about that. I guess I can reference geometry now. I'm in the part studio, so the assembly is just a ghost that's turned up because I'm editing context. I can use geometry, for example, the vibraphone plates. Can I? Yes. And now something happens in my feature tree. It was first when I started using the geometry that this turned up. Mm-hmm. So is it correct that before I'm referencing anything, it's just a visual aid and I'm not making a single connection? But the moment I'm referencing something here in this context, this starts to happen in the feature tree.
That's right. And when that does happen, like when you start doing selection of other things in the assembly, what it's doing is sort of copying and pasting that geometry into the part studio at whatever positions those things are at. So if I go check on these sketches here, you did the sketch and it, we'll just go ahead and do another one of these. We'll do use again. All of the purple geometry is like the copy and pasted surfaces that show up. They're like kind of ghosted in. And if you hide the assembly context, all of those surfaces still remain. You can actually select everything in here as well. The dangers of doing this are contexts don't live update. Contexts are things that you manually need to update.
Oh, it's
So-
they're frozen in time when they at that
Yes.
time. Because some more context I want to give about this context issue, that all of a sudden I by mistake created 2 contexts and I couldn't update. Like I couldn't move stuff around. I got kind of stuck. Everything broke, kind of.
Right. And that can happen as well because and this might be different based on the latest update. I should try this out. But I don't work in context very often at all, so I haven't actually done this lately.
Oh, so
but
you're not using contexts basically, and
I use it for very specific things and very limited scope. So Evan Reese's example from his video that I probably should forward to you is he uses it for like cable harnesses where you're going from point to point in an assembly. So if I were to go in Marble Machine context, not you.
I'm going to have Bowden cables all over this machine, so perhaps this is...
Bowden cables are a great place to do that. That is like the quintessential case study for where you want context and where it's good to use context.
Okay. You have the
where you'll
jitter
do, like, a routing
issue
curve.
is back on your screen. I don't know. Do we want to update that? What do you think, Hannes, or should we just leave it in?
It's pretty quick to update, and it makes it a whole lot more enjoyable.
Yeah, it's
Switch over to your screen, and then Derek can reshare his screen.
reshare and then do the frame rate thing again, please.
Yeah, and while you do that, I just want to echo what Stian says. Learning from competent people is so awesome. So many aha moments that are so obvious in hindsight. I guess
Yeah.
that's how you're feeling, Martin.
Also, like small little stuff, seeing Derek do small little stuff. Not only like the thin extrude, for example, that Derek's extruding a whole body from one single sketch. I never knew that was possible. I thought it was a rule in Onshape that you need a solid like face in a sketch to be able to extrude something. So that trick only, like was not on our list. Yeah, that's exactly how I feel. So the small little stuff that Derek is doing in between explanations, I'm learning so much from that.
It's a masterclass. And also, the audience is having your back, Martin. Derek misses naming parts too. Ha 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 ha.
4 ha ha. Like 2 is the normal one. 3 is when you're really laughing. 4, that's when you want to really degrade someone. No, what was the word? Oh, sorry.
Let's get back to the class.
Okay.
I mean, not to turn this into CAD hot takes, but I don't think part names matter. I think everything should be auto spooling and just everything in a part studio is just numbered in sequence, and that's fine. Part studios, those should be named.
Okay.
Parts themselves,
It's a little dig on me and the chats last week we had. Okay. It's kind of cool. It takes a lot of time to name, actually.
Yeah.
It does.
Yeah.
I have an auto naming script that just goes and like takes everything and names it by material.
course you do.
But a little bit out of scope. Well, I mean,
Yeah.
anything I've ever done like more than twice, I hate doing something twice. I try to find any workaround not that. I want to solve new problems, Hannes.
Yeah.
Yeah. Yeah, I get it.
The jitter is there. We're gonna have to live with it. It's smooth sometimes. Let's just live with it. We understand everything you're showing. It's no problem.
And just
Let me make
quickly
sure I
here,
did hit
from
that button. I think I
Colonel.
did.
Honestly, the thin extrusion is going to be a life changer. I'm going to constantly use it. You see, the audience is also learning good stuff today.
For everyone's benefit, I want to show you the limitation of thin extrude because it's going to come up and I'd rather hear about it, on stream rather than a secondary stream. So when you're doing thin extrudes, the thing that Onshape doesn't like is if I do something like this. If I change this sketch to something like this, I want a middle span here. That's going to break thin extrude.
That was really good.
That
You
being
showed
said,
that.
thin extrude network, an Evan Reese feature.
What do you mean? Do you mean in the standard feature you can't go back in and choose that middle line and add that to the thin extrude?
Thin extrude doesn't like branches. So if I do, things that are like simple geometries that don't have bridges between them, thin extrude is going to be fine. It's when you have T-junctions or multiple edges in a network that it freaks out. But there are custom features that do multiple individual segments, one of which is Evan Reese's network extrude, which I just tried and wasn't able to get it to work. For some reason. Is he not filtering for construction lines?
Evan.
Could be.
Evan.
Yep.
Homework.
Evan.
Evan!
There's a rumor Evan Reese is also perhaps offering some help with the Mar Machine project. Evan and Derek are great friends, it seem like, and so Evan Reese is another fantastic. What's the name of Evan's YouTube channel?
The Onshape.
The Onshape.
Onshore.
Yeah, we should shout that out because that's a super wealth of information.
Actually, I think his channel is just Evan Reese, but his title website business is the Onshape.
He's doing the
we'll
heavy
description
carrying
somewhere.
for you in Onshape is how I interpret that business name. Which is what they're
Yeah, and if you're a business who wants like Onshape guidance from someone who's not me, I'm only here for the Marble Machine project. I can't dedicate full business hours to this kind of advice. But if you want this kind of advice, Evan is there for it. Right, but Thin Extrude Network gets around that limitation. Other custom features exist that do this as well. This is just the one that I have usually for this kind of thing. So when you go try this out and you have branching networks of Sketch, that's what will happen and how you can get around it.
That was good. It is annoying with the jitter issue. I think everyone, because we're enjoying this so much, should we try? What did you do last? I'll go to my screen, Derek. What did you try last when it was fixed?
So all I've been doing is I've been sharing the window, same window, that one there, and I switched that to optimize.
Yeah, it's still jittery.
How's
A
that?
bit less.
Oh,
Looks better now.
okay. I think we have to live with it. Just everyone, we tried. Now we're on your screen again. We tried getting rid of it. We're gonna see afterwards what this is about. It's still we're screen sharing from the other side of the world, so we're doing our best here. Strange. So what were we talking about? We were talking about context.
Right.
And when you thought Bowden cable was actually the use case for context. So just to help me, I should avoid creating contexts. And if I okay, I'm going to go back to my screen because I want to ask this question real quick. How
That's very jittery.
Can I delete this context?
So that was what I was trying to get across to the chat, and the way that I tried. Let's go back over to that tab actually.
Yeah, I'll go over to your screen.
Drum is what we were editing, right?
Yeah.
We'll do edit in context 1, and then we're gonna do the click that is done. We're gonna edit this. And sketch diagnostics profile. Nope, profile inspector is finding like loose ends or like small geometry. If you have imports from DXFs, that might be helpful. Okay, this is what I was looking for, is the in context look. If you delete all these, they become unconstrained because they were from import geometry, but now they're unreferential, and you see the arrow disappeared.
Oh, perfect. So I can go. Do you do that sometimes? Just go in and grab the information with unconstrained and then delete them, or don't you ever like do that trick to get the geometry without having the context?
I think I avoid the workflow so much that it never comes up. But if I was to do something in context and then like need it to be need to update some things in context, but not that others, I think that would be useful. Largely, I just avoid it. I try to put information at the master level, either in the blob or Actually, the one thing that I do use in context for that isn't like routing curve stuff is sometimes I'll use that polymates feature that I showed off earlier. I might have like multiple mate connectors defined in one studio that I want to transfer to another one.
Okay,
Usually, it just doesn't come up for
yeah,
sketches.
basically no. I get it. Sounds good. I'll stay clear of it.
Now
Cast it into
there
the
are
fire.
Yeah.
two real instances that assembly context is actually genuinely useful. The one that if you go through the like standard tutorials that Onshape gives for like beginners to Onshape as a platform was like a movable carriage that has an end stop on one side that has like a detent that it wants to hook up to. And then that same carriage moved physically across the assembly has context number 2. So you create context 1 when it's slid all the way at like bottom position, and then create context 2 at the other position, and then do another sketch that references different geometry on the other side. And it does cuts on both ends so that you get a nice like click detent with a mobile assembly. That's the kind of thing that would be hard to achieve with a master modeling like derived workflow. But it's like sort of representative of the philosophy of context should be minimal and like serve only one purpose and not driving the entire assembly structure, if that makes sense.
That makes a whole lot of sense. Whole lot of sense. I would love to get to the last point because that's what has been such a big issue. Can we move to the blob mania? You think?
I think so.
Ooh, blobs.
Nice. So let me intro this. We're gonna do blob mania, working with blobs. Why is it called blobs? Shapes and sizes of blobs. How would Derek shape the variable from blob? Positions of blobs. When to sketch them in place and when to transform them in place. How would Derek shape the marble gate blob, the control blob, the funnel blob? Let me show you here in my blob space. This is the master part method that Derek taught me. That has done. I have to say it again, Derek. Thank you so much, because not only is this a perfect tool, it's been like an inspiration for me. Like now this for this project, I feel it's like it's like Galadriel gives the light to Frodo, you know, to fight off the spider. The master part model has been that little light for me when I'm walking through Mordor with Sam. That's like, it was like a new way for me to work, which feels so fresh. So it's been so fun working with the Master Part Studio, and it really works. But there is this one lingering issue. For gears, the discs feels great. I was chatting with Derek about removing the spokes from the blob, and I got a little praise from my teacher. Derek says like, those are some nice looking blobs, because blobs. And I think I'm going to go a little bit ahead and say that you named them blobs to inform your team to keep them as rudimentary as possible, right?
More or less.
Yeah.
This idea of the master part method isn't mine. It's something that a lot of industries do by other names. Sometimes they'll call it the like a master skeleton part. But I think the name skeleton is trying to, it leads your imagination the wrong direction, where you try to do things in 2D with a sketch. And, you know, I don't do things with sketches when possible because a lot of my projects are very 3-dimensional and cannot be represented by pure 2D line work. And you saw that there were, you know, shortcomings to the sketch method.
Yep.
So by calling it blobs, it does two things. Number one, it teaches you that these things are meant to be 3-dimensional structures that are not purely planar and like not purely like an XYZ like projection view of these parts. They can be cylinders like tilted at some random XYZ rotational angle. They can be polyhedrons that have multiple faces that are a pure like rock form sculpture that you're going to be making out of. The other thing it does is by calling them blobs, it's attracting the imagination that like these are not meant to be final, like full detailed structures. Mm-hmm. They should really just be like a squint interpretation. Like if you stand a mile away and you like close your eyes like half, that's what a blob should be, is what you can make out by that metric, because it's supposed to be, you stick to the prime datums that are relevant to the lower subassemblies. And the reason for that is, you know, we even in this minimal master part model, we have 134 features. The build time is very snappy at 621 milliseconds because all of these features are very simple primitives. When you get to the gear teeth, you went that far with these. Every single part that is not one of those parts that gets loaded from this part studio has to pay the debt from those features.
Yeah.
So when I first started teaching projects, people were putting too much information into their blobs, finding out that their build times were horrendous. And then every single part studio, when you open it up, first feature has a 20-second build time.
Yeah.
Those projects take forever.
That's great info. And then back to my issue that I want you to help me with here. The gears, simple, cylinders. The shafts, perfect. I like making shafts for stuff that I'm going to place later. It's like, but then I run into this things. How do I shape a blob? Let's start with, let's run through them a little bit quick. How do I start a blob for a marble gate that I don't even have designed yet? And these a little bit more, like how do I start a blob for the vibraphone? How do I start a blob for these funnels? For the funnels, I did the pivot shaft just to start with something, but that's also not really good. The thing that goes bad with that is that a blob should also be a space claim, because I want to see in here that, oh, I can't actually put stuff here because the vibraphone is in the way, but this is my vibraphone blob, and this doesn't tell me in this view. So perhaps should I then I'm saying multiple questions here. I'm gonna choose one question at the end of this rant. But the vibraphone blob, should that be the bounding box for the entire vibraphone, just to tell other parts to stay out of the vibraphone space in this? Because it looks like I can put things here, I can't, and then when I go to master assembly, then I see that they are colliding. And so, for example, this turned out, no, that's not it actually. Did I actually hide the, no. I think I just made like, what is the blob actually for? Oh, the gates. Yeah, this is the blob for the gates. And then what I did when I went into the parser, because this is so rough, I just sketched on the plane of this blob. I had no idea in my brain how to translate a nice shape of this blob to the marble gate. So perhaps instead of going exactly on the marble gates, can you talk us through like what should inform our blob shapes?
So your instinct of these things being like keep out zones is pretty much exactly right. Where in the vibraphone case, what's important to you is, you know, the contact surface, the top, all the vibraphone bars. I assume you want them all aligned and planar and like nice in a row, which does help with the consistency of the droppers later on. So this top rectangular extrude here is a good prime surface. But if you were to do a bounding box that came all the way down, I don't know if I can edit this sketch because I think this was done. Yeah, it was done here. I'm going to just hide this blob real quick and we'll do a new one. Do you have a center plane?
Just a default plane.
Oh, because you did the shift. Okay.
Default right is the center plane.
So we'll do a sketch on the right plane, and if I were to try to line that up here, oh wait, I could probably do that. Yeah, we'll just edit that.
That's the second vibraphone blob I did. I just did one bar. When I started with vibraphone 2, I did one bar only because I didn't like my first blob. But I also don't think one bar is good.
I'm gonna delete all of this stuff here.
Yeah, I'm used to you deleting my stuff. So it feels, you deleting one sketch feels good compared to what happened in the beginning of the stream.
My coworkers are gonna rip me for that later. Like, you do it to him too. He was so nice and invited you on. Yeah, so let's go do like the full box out. Like we'll do a a full keep away. Maybe there's a support that needs to go up in here that like does the swing arms rather than just the vibraphone itself. Maybe those aren't fully at the same angle. Maybe they come down a little bit.
Okay, so I want to go back to, now when I see you do this, you said like squint. So if you stand like 100 meters from the machine and you squint, that's what a vibraphone would kind of look like from 100 meters.
Not yet, but it will. Something like that.
Because Derek gave me the advice that I should consume the blob part in the beginning of the tree, and that kind of, which means that you're gonna show that in the next part studio. But that threw me a little bit off. Also, I think, Derek, because I don't know how to. It feels wrong to consume that big blue box into a single little vibraphone bar, for example, if that's where I start off the vibraphone. But
so, like most of my advice, the consuming thing is not a hard and fast rule. What it is a good default to stick to, and what it does for you is it gives you good stable references for later on when you do your assembly inserts. The mate connector is attached to that part, and if that blob was the beginner like part that derived everything, or like that generated all the rest of the geometry by being consumed.
Let's show them what we're meaning by consumed, so everyone is on board here. So let's name this part. It's already vibraphone 2, and then actually, if you go into vibraphone 2 part studio, you can start over, yeah. So
well, let's see what we broke.
Yeah,
it's fine. We'll just go make a new one. It's fine.
Yeah. So let's show everyone what you mean with consume. So when we derive this into a new part studio, sorry everyone for the jitter. We tried to fix it. We can't fix it right now. We just want to go for the knowledge instead. I think everyone will be able to follow. Derek is deriving this into a new part studio, and we're gonna show you what about consuming the blob is in the new part studio. So it's vibraphone. You can search for vibraphone 2. There we go. It looks like you're very nervous in the jitter. Like this is the first time Derek is catting. You look cool, calm and collected on camera though. So now if you see in the parts list, we have a part called vibraphone 2. And perhaps this is a strange example, but Derek's first advice for me was to do the first shape with that part. Okay.
Right. And the reason is because you have access to certain features. Like if you're doing frame geometry, sometimes you can do, shell features can get you frame looking geometry. And because you have the ability to use some of these non-sketch based features to generate like solids, if this were a functional part that I did more to, maybe we'll just do the backside as well so that this looks kind of like a part you might do. And then you go to insert this into the assembly and you attach mate connectors to this.
Yep.
If I later change things about this, if I change the blob so that instead of having a nice squared top, maybe I switch to like arcs or splines or something, and the geometry of this fundamentally changes, because this derive operation is inserting the part, like the vibraphone 2 part from that studio, anything that references vibraphone 2 in the assembly, or the part identified as vibraphone 2 in the assembly, is going to remain stably attached to it.
Yep.
In the case of the vibraphone,
the other alternative I just want to say would be for you to start a sketching on that part, and extrude a new part, and then just hide the original blob, and then it's less stable, because then maybe by mistake you add the mate connectors. First of all, you have a hidden part in your parts tree which feels bloaty, and then you add mate connectors to the wrong part.
So the two ways around that are, number one, you could just delete the part, and now it's not in the tree, and that's fine. And you'll do that in sketch cases where you don't want to, you don't feel it's proper to like actually consume the part, like you just can't wrap your head around it, or maybe it just doesn't make sense to. You're just using this as the bounding box check for all of the components that are in the studio. That's okay. all you need to do is put a delete part at the end of your feature tree and then make sure that that goes away. But if you do this, you need to make sure that whatever else you're inserting into the assembly, let's say we'll do a sketch on this side. Actually, let's do it on the top so that it's like more vibraphony. I don't know what scale this is, but
I can,
you know.
It's a good try, Derek.
I think it's more Discord than that, I'll be honest. There you go.
Only 3 notes though. You made 6 and I only played 3.
So when we delete this part, if something was attached to vibraphone to this body in the assembly, the mate connectors will lose their reference when that goes away. So what you need to do instead is figure out which of these parts is least likely to disappear in future operations. So maybe that's the root note, like the bottom of the scale or whatever. Maybe there's a crossbar that you're always going to have that same crossbar. You just need to make sure that when you do your mate connectors, they're attached to something more stable.
Okay.
That's the biggest note here. I'm going to say attached to that.
Okay, because this thing scared me away from making bounding boxes, which is make my blob space isn't working as good as it could. I changed to my screen here. Now we clearly see here in blob space that we can't put anything here where the vibraphone is. By the way, Derek is working in the same document as I am, so all of a sudden Derek's parts turns up on my screen here in my studio. It's fantastic collaboration feeling. All right, so shape, that's the consuming part. That's not a hard rule. That's very, very, very nice for me to know. It's okay to delete the part. That's also nice to know as long as we do the mating correctly. So what more about blob shapes, Derek? Should we go for the vibraphone or should we jump to another example?
Staying on the vibraphone actually might be worth it because there is another bit of minutia here that maybe isn't obvious. Master parts being like all top-down controlled, there's nothing to tell you that you need to stick to one level of master control. You can actually chain multiple levels of blobs. So let's say you wanted to set this whole zone aside for vibraphone stuff, but what you really need is some like sliced up version of this where you want to like figure out how many notes are available to fit in this bounding box. Like your master model has already decided, okay, that's the top plane for sure of all these notes. Here's the maximum extents XYZ that I'm allowed to put stuff based on the master assembly. But where do my individual vibraphone notes go in here? You might do that. Simplest way, do a sketch and then like do a bunch of lines crossing and split the whole thing up. So we'll do that now. I'll do a couple of those. Very uneven spacing. Maybe it's better to do like a single split and then like pattern so that they are all consistent widths, but maybe your vibraphone parts aren't consistent widths. And instead of doing this extrude as a new, we're going to do thin and we're going to do remove. And just cut all the way through.
Wow, I always cut with, I always did rectangles. Derek is using only lines, thanks to thin extrude. Super cool. That's
and we're going to call this one.
You know how I always did that, Derek? I always did rectangles, and then I linear patterned the rectangle, and then I clicked every single face, or I did a linear pattern on with the thin extrude. It's so much simpler.
So for like general reference, I try to make it so that anytime I'm working with a sketch, the purpose of that sketch is so that I can select the entire sketch as my operating thing. That way, if I go to
say that again, I destroyed it by talking over you. Say that again, but say it slowly. This is fantastic thing. Say it again.
when I create sketches, my general approach is to try to make the sketch able to be selected as an entire query so that I don't have to go back and select individual edges.
Wait.
Applause.
Switch Johannes.
Yes.
Oh my God, that's fantastic.
Words to live
there.
by.
that is amazing. So, but then, would you then would that lead you to create like 3 sketches sometimes to just use them as tools in the feature tree?
Yep.
And
Often do. And sometimes those sketches like just don't reference each other at all. Sometimes they like refer to like further operations down. I say I don't use sketches to be facetious. What I really mean by that is that my sketches are like very simple, like 4 lines. Otherwise, I just stop paying attention because I can't bother myself to go back and fix them. And then I follow up with features that do the true design intent things. General practices.
that's super inspiring. So you rather have, instead of representing like 3 ideas in one sketch, you rather do a single sketch, some features, another sketch that represents idea 2, another sketch that represents idea 3, so you can just click them and work and use them like that.
Yeah, and there's a lot of reasons for that. I mean, like, number one, the ability to just go in here and then just window select everything and just delete it and start over. You can't do that if everything's in the same sketch. It's all interrelated, and you have to go back and try to selectively play surgery. It keeps your sketches lighter. The other big reason for this, and it's hard to tell because the sketch only has one component, but sketches are features by themselves. They have their own rebuild time. And unlike everything else in Onshape's feature hierarchy, these need to rebuild by, like, they're not sequential in their build order. So if I were to start going in here and add like 800 lines that all have to be resolved with open areas, regions of like closure, the big example is like imported DXFs. I've had clients send over like full architectural building layouts, literally everything in the kitchen sink. And then we're supposed to install an exhibit in the middle of that document, and I have an 80,000 line sketch to work with. Step number 1 is always delete everything that's not relevant, because all of those intersections, all of those vertical and horizontal constraints, all of the regions need to build in order sequentially. And DXF imports are the most horrendous thing for build time in my usual work. Because it's just an overload of geometry. It has to spend time chewing through all of it.
Yeah, that's a fantastic lesson we're getting from Derek here. Just me, I don't know, coming from Fusion 360 if this is but Fusion 360 struggled with sketches. I did, when I did some helical gears in Onshape, I circular patterned the gear tooth, the convolute gear tooth, involute gear tooth, convolute involute. Never mind. Pattern. I circular patterned the sketch lines, not an extrude like a part, and Onshape didn't play nice with that. So it's a fantastic lesson from Derek here. I start to understand why you hate sketches. So, but let's go on with the blob shapes. Yeah, we have we're 12 minutes before we are going to wrap up, and it would be nice if there is any audience that has a question for Derek, perhaps. But finish your train of thoughts on the blob shapes, Derek.
Okay, so what I was going to say is that there's no reason that you need to like constrain yourself to one layer of blobs. I mean, this has the drive import. It's very lightweight at 58 milliseconds, 56 milliseconds. And for the vibraphone, if you're going to be doing the rest of what we talked about with a configurable studio, all that you really care about is, you know, how many of these can I fit in here? So I'm actually going to go back and delete everything that's not one of these. We're going to show off that linear pattern capability here. And I suppose I could show off Evan's linear pattern plus, but we're just going to stick to the defaults for now.
Yes, the defaults, Hannes.
Bare bones.
Bare bones.
And I assume you know what the width of all your vibraphones is. I'm going to say that they're 50 millimeters wide here, 40 millimeters wide. And we're just going to see how many of these fit in the space. and apply those. Reapply features, remembering from before.
Yep.
And I should probably take this initial sketch and then add that as a dimension off of the one side to figure out how many of these I can fit. I suppose one good way to put it is that with blobs, there are like two different methods of thinking about them. There's the descriptive blobs, which are like this, where you have a known width of something. You want to try to match purchase part dimensions or things that are like already like not custom. They're things that are set in stone. And then there's prescriptive blobs, like the initial seed of this, where it's here's how much room I got to fit things. That's immutable from like the laws of geometry.
So that might help me with my blob shaping issue. Descriptive is when they look like the final part. Prescriptive is more of space claim stuff.
Right. And I tend to put things into like if it's prescriptive, it should be top level, or like very near top level. If it's descriptive, it should probably be secondary unless it's like a really big component. I don't know. There might be a programming wheel manufacturer that sells these things and they sell 4 sizes. If that were the case, you would import that and then pick the size and it would go top level because it's such a huge component of the machine. But it would be a descriptive blob, not a prescriptive blob. Well, it's kind of both because it is top level. It's keeping away everything else. But in this case, all of these little slices are going to be descriptive, and I'm going to flip that the other way because that's what matters to me. And I know that I can do in this arbitrary scale that has no, well, it does have relation to the master model because we zoned it out. This doesn't intersect with anything important. No, we're good. Maybe crash symbols a little in the way, but we can fit 40 notes in here according to this. And now I have this one main segment here, which is just on the end, and I would derive that into a new studio, that one main vibraphone segment, and we're going to go work out of that.
Now we're on our second tier of blobs. So you go on deriving, because now we're going to have a repetitive assembly with the pivoting arms, and then we only want to work on one channel.
Interesting that was a much higher build time. Why would that be the case? Because there's a lot else going on in there. That's why. That's okay. We can suppress this, and that will fix that issue.
Okay, that's flying over my head, but that's okay. Okay, so now now you're going into another level of blobs.
Yeah, and then this is like the minimal like bounding box for just this assembly. This is where you would start doing your configurable part studios, where you would do configuration variables to set up like here's the vibraphone bar length. Here are all of my sketches that are bounded like on the midplane of just this segment. If you had lifter arms that had to fit in here, that would go in there as well. And this is like the shadow zone where you put everything into. Your parts your blobs can be more complicated than this if you needed to do stuff like out of plane, like add a bump out that was like staggered segment to segment. But this is the general kind of idea, right? Where you're doing big top level stuff, slicing it up into smaller chunks, working within those chunks, and then inserting things back into the assembly and building it all back up from the roots.
So cool. How often do you do 2 level of blobs or more?
I want to say that I've seen as many as 5 in a project, but I don't think that was the correct architecture for that project. I think 2 is often for parts or like projects of the complexity of a marble machine. If you're going to do something at like a building level where you're doing an entire gallery of stuff like we do sometimes, I think that anything less than 3 would be unwise, but then you run into that DXF issue that I was talking about where you really got to plan around things. So it's not like a one size fits all approach. It's just sort of dependent on your workflow and your understanding of things.
Yeah.
And a lot of it is it's constrained by these load times in certain subassemblies. So you always have to keep that in mind.
You know what I just discovered? Derek has named this blob to Electric Boogaloo, and I actually wrote a song once for my jazz band called Tuesday Morning Boogaloo. Ah. See? Coincidence? I think not. Okay, my brain is full, and my heart,
Same brain cell.
my heart is full as well. What do you say, Hannes? What is there time for and Derek, of course? What is there any questions? Is there any questions for Derek from the chat or?
Not really yet, but you have a couple of seconds, chat, to write some questions. I have some feedback for you here from today's stream. Here from David. This stream has already answered so many questions for me. Martin is asking the exact right questions.
Oh, glad to hear.
And then we need to rewatch it another 500 times from Bog SP.
I've been feeling like that. And like, okay, I think I know what Derek says. I'm gonna rewatch it.
And I love this as well. Dang, so much content, ton of knowledge transfer. That's a beautiful way to put it.
Yeah, I think I'm like, I try also to be honest when I'm not always catching everything, Derek, what you're saying on the first go. So that's why I'm trying to sometimes also ask like, but wait, what does that actually mean? But like the general direction that you're pointing out for me in the project feels like super clear to me now.
Martin wants to know, Derek, how would you rate Martin as of right now?
So I'm going to be honest with everybody here in the chat and like in the stream as well. I have taught a lot of new drafters, new to drafting and new to Onshape people. The speed that Martin has picked up some of these topics has been one of the faster people that I've taught CAD modeling practices. Now, he's also got 10 years of Fusion experience in front of him, so a lot of the stuff does transfer. But yeah, I would say he's a solid 8 or 9 out of 10 as a student.
Whoa!
8 out of 10.
I don't even have to do the marble machine now. My life is fulfilled. Thank you. That was sweet.
We have a question here from David to Derek. Earlier, you showed how to parameterize a part studio using variables with minimum maximum limits. I forgot the exact name. My question is, does it make sense to do that in the master part?
So the master part is the one place it does not make sense to do that kind of thing because unless you're doing something that is a full configurable product line, in the marble machines context, we're only building one of these. So the dimensions of the vibraphone blob need to be the one that needs to be made. If you are making something as a product, let's say it's at a truck trailer or something, and you want to do an 8-foot trailer, a 10-foot trailer, a 12-foot trailer, that is where it would make sense to do a top-level configurable configuration variable. Relevant for some projects, just not this one.
Perfect. And I just saw here also, Martin, from 2 Minute Papers. Martin is the best.
Oh, 2 Minute Papers is the best. 2 Minute Papers, I have a story for you because we met DeepMind yesterday, me and my friend Don, and your video about this hybrid thing that I think you released like 2 days ago. We actually discussed that video with the higher up at DeepMind like yesterday. So you came up. I'm absolutely pretty sure it's your video. I'm going to shout out this video. I just wanna go find it. For everyone not knowing, 2 Minute Papers YouTube channel is an amazing channel about AI science. Let me see what the video was called that we discussed with DeepMind yesterday.
And I will put this up here for you to think about, Derek, while Martin answers here. Any suggestions for Martin to focus on from today? So you can think about that for a couple of seconds, but while Martin looks up the video.
I see that it's called DeepMind's new AI just changed science forever, and it's only 1 day ago. But I think it was your video that we were. Oh, my camera is not focused. 2 Minute Papers is a YouTube channel. So honored to have you on this stream.
Okay. So, Derek, any suggestions for Martin?
Well, I was also going to say on the 2-minute paper subject, it's not just AI videos he does. He actually does graphics programming, sometimes other like optimizing algorithms. I've watched several of his videos, and some of the white papers that he's highlighted has ended up in my custom features. So shout out to that guy.
Wow, that's cool.
Worlds colliding.
Oh, this is a great question. Yeah. And
homework for Martin is the question, from what I take it. And number one, I think, is the configuration variable, and like figuring out how to use those as
Can you
a
switch over to Derek's
control
screen,
method.
Martin?
yeah.
There we go.
Let's go back to the configurable gears document. Doing some CAD calisthenics with these configuration variables and like playing with these values specified on the right side of the screen for your common use parts is going to pay dividends in the long run for your project.
What is
so
CAD
I would-
calisthenics?
You training.
Yeah, it's training. It's doing something that may not be like 100% applicable to the final product, but builds the skills that you'd be using. I think Too Tall Toby calls his like CAD tutorial series like CAD calisthenics sometimes. I could be wrong about that. I think it might be people referring to his videos, but it's that kind of thing where it's practice, but not necessarily towards final parts.
Okay, configurations in part series. Could you go like a little project wide? We had so much golden content in from that we didn't release yet from our first talk, Derek. You gave me some like project wide advice, but like project wide. If we zoom out of Onshape, I mean, you have designed and shipped a lot of projects, and you ship them. Any advice for me to actually finish this project?
So it's going to come back to the design requirements discussion, and the lesson you learned on that last stream about why did we go wide with the vibraphone is exactly the kind of thing that those design requirements documents are supposed to inform. And we run into that as well from a client-facing perspective where, we as the engineering staff get handed off documents from our design team. And though they're in the same building, they're usually working on other projects. So it's hard to sometimes get design intent from their mouths because they're on some other calls for the next gig 8 months down the line. Even worse than that, they're not often the people that have those decisions baked into their heads. It's sometimes the client that, a client or a contributor, like a financial contributor, stakeholder in the project that has said, no, we need to do these patterns on these parts specifically because it's a tie-in for the local wildlife. Those kinds of decisions that are like descriptors for the final build and like why something is the way that it is are invaluable, because you can spend months working on a project and then not hit one of those requirements, show it off in a design review, and then it's not what was intended from the get-go. Or worse, you end up having an internal requirement that you didn't check. For example, the minimum access way size, like everything that we build has to go fit into trucks and then fit through the smallest doorway on site. I have been in charge of multiple projects where we didn't fully check all the boxes for that, where we didn't have a prescribed minimum access way. And people have had to pull out the angle grinder on site, cut parts in half, our beautiful like 6-month-long projects, getting butchered on site and having to get welded back together and repainted. And you spend an extra 3 days of install time trying to figure out how to take the plan and adapt it on site. Setting requirements that are concrete deliverables and like describing why something is the way that it is are helpful when you're in the weeds 6 months down the line and you forget why something was the way that it was, but even if it is a solo project.
But so you mean even for me then? So if you would allocate if you were my boss, how like tomorrow, like on Monday, me and Hannes is here on stream 9 o'clock in the morning. How would you allocate my time between trying to get grips with my design requirements or designing in CAD?
I mean, if it's the design requirements, it's honestly like a review of a lot of the previous videos that you've made and like describing why the silicone dampers are important for the vibraphone, or why the 2-channel switching for the vibraphone was an important innovation, and like putting those to document so that later on, and organizing them so that they're all like vibraphone requirements, like this position over to that position, you can glance over the document and go, okay, I just moved something fundamental about this machine. What does that affect? Do I now need to like sacrifice one of these elements? Is sacrificing that element something that I can live with?
Yeah, it sounds great. It's just that like it feels like I will spend. It's like another. I will spend so much time, and I know that's engineering. You spend time preparing, and in the end, it comes out something better. The more time you spend, 80% preparing and 20% delivering is going to be better than the other way around. So, but it just feels like. But on my time allocation question, would you have me? Because what I envision is that I will start day to day when I'm CADing, also writing requirements day to day, and then slowly build up the requirements. Or are you suggesting I take a month break from designing and just wrap my head around requirements?
I don't know if it needs to be a month break, but certainly like a substantial amount of time should be invested. This project is of a level of complexity that there's no way you're going to keep every single decision in your head at all times for all components of the machine. And it's that way for our projects as well. Like we'll be working on something at one side of the gallery that has nothing implicit to do with the other side of the gallery, and you're just focused on that specifically. But then we'll do a design review of our project, project manager, the engineer in charge, maybe design if it's relevant, probably not. And we'll go review the design requirements and then the current state of just that component and say, does this satisfy what we had set forward to do? And a lot of times it doesn't, and we have to go back and adjust the design.
Okay. That's not the medicine I wanted, but it's the medicine I need.
Tough pill to swallow.
Yeah, tough pill to swallow. That's awesome, Derek. So basically, just high level, you just urge me to not give up on the requirements. Is to summarize?
Right. And I wouldn't say that you have to go like absolutely like overboard with the details of those requirements. I think that it was somewhat in jest the like must have a vibraphone. Verified by looks like it has a vibraphone. That's a requirement actually, and we've had projects where we have not looked at the design requirements and then fully missed an entire part of the sales like bill of materials deliverable and had to scramble. It doesn't happen often, but it does happen sometimes where you want to make sure that everything that the end client, in this case, this is going to be past Martin, is your future end client, if that makes sense. Everything that you wanted to do ends up in the machine.
Yeah, you wrote something for me that was helpful. So okay, I want to do something that I didn't even dream of that I was capable with this machine, and like it's like all the roads lead to like if I can internalize how designing with requirements actually can empower me as a designer, I think that is going to be the unlock. Like, and also like we have some other stuff in place now. The structure me and Hannes have now is on a completely different level. Last autumn, I sat in my studio, played chess on chess.com. So we're doing so well, but I can attribute a lot of this feeling of that we're gonna have success to your help, Derek. So I can't thank you enough. Do we have another question from the chat, Hannes, or are we going to
not questions? But I have some wonderful news here that we have Florian as a new backer on YouTube with a question, or not a question, a statement. Florian says, "Thank you so much for your time and knowledge, Derek. This was an awesome learning experience for me as a hobby CAD dabbler. And thanks for inspiring me with your perseverance and tenacity, Martin. I believe." Thank you so much for that generous donation as well, Florian. That's awesome. And Martin with a little statement here as well. Not preparing right is preparing for failure. So Martin, with kind of echoing what Derek is trying to say, I think.
Yeah.
Well, and I will say that there is also a freeing aspect of some design requirements where sometimes when I'm coaching people on my team about how to approach part of the build, they'll come up with some really cool, innovative concept of how to approach those parts and designs. And I hate to break their heart sometimes, but I have to go and say, that's an awesome thing that you prototyped, but it's also not what the client bought. And so we're going to have to save that for the next one. And we'll go ahead and put that into a box and set it aside and just come back to strictly what was on paper.
Wait. This is another like of this moment that happens a lot with you, Derek, when you say something and I'm like, hold on, what you said there was very important, because I'm going to translate to everyone what you just said, how that landed in me. If I do some design requirements, when I get to these really tough emotional decisions of letting go of some fun ideas I have in my head, I can hold on to the requirements. I can hold on to my papers of my design requirement, and I can like look at them now. Okay, Martin, it's a cool idea, and it says here in the paper that you just cannot include it in this machine. Let it go. And that's the freeing aspect you were alluding to, I guess.
Exactly.
Wow.
Fantastic. Wow, what a day. What a stream. Derek, what a pro. This was fantastic. Can't thank you enough for joining the stream, Derek. This was awesome.
Wait, the cat is coming. The cat is coming.
I was going to say, special guest arrived at the end.
Oh my God. We should have led with this. Oh, yeah.
She would not sit around for 3 hours.
Yeah, let's do an outro. Let's say just huge thanks to Derek. How do we outro this? I think you need to outro this, Hannes.
Yeah, I will just start. You can't play, sadly, today. But thank you so much for tuning in, everyone. And we see you on Monday.
Thank you, everyone.